Good morning, everyone. Good morning, good morning. Happy Wednesday. How's everyone doing? Awake? Yeah, good. Welcome to AI User Conference Developer Day. My name is Jackson. I will be your host, and I am one of the AI User Conference organizers. I'm also one of the organizers of AI User Group. AI User Conference is an AI User Group initiative. AI User Group is a community interested in learning about the latest Gen AI tools and how to apply them to our current professional day-to-day. So we host this annual conference. In addition, we have monthly meetups here in San Francisco, so you can find our meetup page. You can follow us on LinkedIn and Twitter. In fact, if you're having a good time today, feel free to mention that you're here. We'd appreciate any mentions on the socials. And just before I get started, I'd just like to make a few announcements. I want to thank our platinum sponsors first and foremost. Lightning AI, Rizzle, Convex. Please go visit their booths. Also, I want to thank AI Alliance. AI Alliance is sponsoring our after party. So at the conclusion of the conference today at 6 p.m., I think we should go have dinner. But at 8 p.m. right here, we're going to have a huge party. So thank you, AI Alliance, for sponsoring this. And be here. If you're a Pro Pass holder, you have a ticket to the after party. So please join us. In addition, I'd like to thank our other sponsors, Simplified, the Chen Institute, Canva, UiPath, Best Ever, Beautiful AI, One Shot AI, CoFrame, Hyperbound, CodeRabbit. CodeRabbit is over there. Please go see them. Please go visit their booth. Cloudflare, also with a booth. Pharos, AirTrain AI, MongoDB, FreePick, AnyScale, OpenArt, Super CMO, Buzzy. Please see all these booths and visit our sponsors. We really appreciate their support to make this all happen for us. What else? I want to thank our community partners, Developer Week, Design Buddies, Silicon Valley Generative AI, AI Tidbits, SFBay, ACM Chapter. They're hosting a panel later, and Women Who Code. So thank you so much for that. I also want to thank our volunteers. Kieran, Auton, Scott, Lena, Sinead, Yiya, Lena, Manas, Rose, Lily, Devinder, Alex, Colby, Benjamin, Christian. Thank you so much. We appreciate you guys. Very helpful. They started setting up on Sunday, and they've helped us every single day, so we really appreciate it. It's made a huge difference for us. One final announcement before we start. If you're curious about the agenda or anything like that, the best way to stay up to date is check AIuserconference.com. So just check the website and click on agenda. So AIuserconference.com, you can sort by main stage, which is here, of course. Workshop 3, which is upstairs. Everyone has access to Workshop 3. Downstairs, Pro Pass holders, you can go to Workshops 1 and 2. So that's the best way to stay up on the agenda. And with that, it's 9 o'clock. So I'd like to introduce our first speaker to get this kicked off. So I just want to say, just one mention. Originally, we had Joe Spizak. He called in yesterday with COVID, so we wish Joe a good recovery, and thanks for giving us notice. We're really lucky to have Alexi. Alexi is Open Source Science Community Director at IBM, and if you want to thank someone for the after party, you want to thank Alexi, trust me. So please help me welcome Alexi.
Thank you, Jackson. It's great to be here. So I want to thank the organizing team. Alexa and Jackson actually reached out to us very recently, right? And this whole thing came together very quickly because the AI Alliance is a fun place. We want to be the main body community for AI in the world, and we want to immediately tell everyone that we love community and we love good parties. So we're going to have the best parties in AI around the world. So please keep an eye on AI Alliance parties. It will be the hottest thing. Now, my name is Alexei Krabarov. I wear many hats, physically, literally, and figuratively. So I lead open source science at IBM Research. It's the initiative to put together open source developers and scientists to advance really hard problems of humanity, such as material discovery, new drugs, climate change, electric batteries, carbon capture, you name it. And we need open source AI to do that. I've been elected the founding chair of Generative AI Commons Linux Foundation, which is basically a Linux Foundation body for generative AI at LFAI and Data Foundation. And we've recently created this AI alliance with Meta, and Joe Spisak is a co-lead on this. So sorry that Joe cannot be here, but we're very fortunate to work with Meta, Joe and PyTorch team. So this is a joint effort. I'm very happy to be able to give this talk and hoping Joe will quickly recover and obviously continue his contributing to PyTorch and Llama, and you will hear from him. So just want to mention that tonight IBM is hosting Bay Area AI Meetup, which I lead. It's completely full. It's a VLLM project from Berkeley. If you're on the list, you will be able to join us, and then everybody there will come back here and join the party which we sponsor at 8 p.m. And also I run this conference called Scale by the Bay. It runs every November. It's a developer conference in Oakland, in a very similar venue, in the Masonic Temple. So I'm really happy we're doing this together with AI User Conference. We have the same taste in community venues. It should be like this, right? Like not a giant hotel. It should be fun and cool place. Now, so what I'm going to talk about briefly is the AI Alliance. Sorry, this is not going to be a talk about specifics of Llama or PyTorch. I'm going to cover what the AI Alliance is and how you can join. So I think the key development in software we've seen with the rise of AI is that last 40 years, we've seen a steady and hard uphill battle of open source to become the way we develop software. And eventually, we got here, right? We believe that open source is the way, software is eating the world, open source is eating software, and so forth. However, since the ascent of ChatGPT, for the first time in these last 40 years, we have a concerted effort to basically shut down open source as the way to do things. And there is a concerted effort to promote the idea of closed development in AI as being safer, to promote legislative capture of AI by various acts to regulate, certify, and control AI software. And basically, we believe, as IBM and Meta and members of the Alliance, that open source AI is the way forward. So we double down on the notion of open source, open data, open science. And so we joined forces. The idea started in June between IBM and Meta, and then we invited multiple partners, including Hugging Face, LangChain, Llama Index, Anyscale. So basically, weights and biases, everybody who believes and practices open source AI. We also are joined by a number of companies that span the world, right? So we launched on December 5th with a set of more than 50 partners. At this point, we have about 75 members. The next batch will be announced on February 8th, and will include Databricks, Snowflake, Uber, and UPenn, major universities and companies around the world. So the idea, and obviously we got a lot of coverage by the media. I think the world is ready for an alliance like this to define what AI is going to be. So what are we going to do, right? First of all, we're going to build. So this is not an alliance of policymakers. We're going to talk policy, but we're going to build AI. So first, we need to unite and get behind key projects in AI, right? So if you look where efforts are going, we've been focused on models, right? A lot of work, and obviously Meta contributes Llama, which is some of the leading families of models. We look at APIs, we look at application frameworks like LangChain and LlamaIndex, and obviously the set of open source RAG stacks. So we want to have a reference stack. If you're a business, it takes a long time to cobble together some kind of architecture for AI. So as an alliance, we aim to give you some easy reference architectures which are applicable to your use cases, so you don't have to read 1,000 blogs and piece them together, right? And obviously, we need to work together as an alliance because everybody wants to be a part of this reference stack. It's a standard setup where it's a competition. We compete, but we cooperate, right? And if similarly to Linux, LAMP stack, Jamstack, and this kind of SMAC stack, these architectures, we put together a good reference stack, then it will be much easier for everybody to actually use it. Now, we enable developers, right? So obviously, if you can build, you should build. Now, if you're in a position to help others build, you should do so. And IBM is fortunate to have enormous amount of resources to bring to bear on this, including GPU banks and data centers, cloud, hybrid cloud, and also it's great engineers, right? So IBM contributed basically for the next several years, huge amount of resources, and so do other large enterprises which join the alliance. So you can enable scientists, for instance, by giving them access to GPUs, and we'll work with our friends at Hugging Face to prioritize open source use and the research use of these resources. But obviously, if you are an open source centric startup, right, you cannot contribute a bunch of GPUs, but you can contribute a lot of advocacy, right? So this is what evangelists, DevRel folks do in this ecosystem. So we rely on our startup members to advocate in a concerted fashion, and obviously Hugging Face is doing a lot of heavy lifting. So by the way, I'm very happy to see that a lot of Alliance members are speaking later today. If you're aware that the company is an Alliance member, raise your hand. If you know, like Hugging Face, Intel, AMD, you may be not yet aware of this, but it's highly likely that your company is a member or will be a member. And advocate, right? So we really need advocacy. We're going to do advocacy around the world, and we have been building this effort for a while, and I think companies like IBM and Meta are experienced in advocating software policy. So we'll bring these resources to bear to educate policymakers, members of Congress, members of parliaments, OECD, and so forth, right? So we plan to brief folks on the Hill, use our media leverage to convey the idea that open source AI is the way to go, and we're ready to work with folks to educate them and explain why shining the light on technology makes it safer. So we believe that making things open source makes them safer. And logistically, we have 6 work streams, right? So we do AI for science, education, and outreach. Then we focus on testing, validation, benchmarking. And we don't need to kind of duplicate the work. For instance, ML Commons, which has an AI safety interest group, is a member of the Alliance. Linux Foundation, with its Generative AI Commons and Life and Data Foundation, is a member of the Alliance, right? So we will smartly delegate and focus our work and basically have folks who do something best do it, right? So if ML Commons can host the benchmarks for safety, then they will do that, but we need to agree, right? We need to agree and come up with criteria that can convince us all that this is the way to do it. And the most interesting thing is that there is no single place, right? Like you cannot go right now to any website as a source of truth. The truth will be arrived at as a consensus of practitioners. And by virtue of having the biggest body of AI in practice and also deployment in industry, we will be able, I think, eventually to become the source of truth on what is a trustworthy and reliable AI deployment. We want to build the best tools, right? So we already have tool makers. We are developer-centric alliance. We want to work with developers to bring technologies like and approaches like test-driven development, CI/CD, and so forth to this area. So it's been a bit of art, dark art. It needs to be a rigorous software engineering discipline. And we see a lot of work emerging, basically kind of building LLM OS, right? The tools are emerging for memory, for distributed systems, and so forth. So a lot of work will be kind of redone in this new era. And so we want to make sure it's done rigorously and serves developers first, because developers are going to build it. We also have a hardware part, which is different from a lot of software alliances. So Intel, Dell, and AMD are leading members of the alliance. Intel contributed its assets and AMD to Linux Foundation, UXL, the new foundation for open accelerators. So I think given what's going on in the AI and the need for inference and training, there will emerge an ecosystem of open hardware to serve this vibrant open source AI. And so we need to work together, and hardware, software co-development is a super exciting area, and I think we'll see much more cross-pollination between software and hardware. Then obviously we have some of the best models, and we'll continue working on the open source foundational models to make them the best, accessible, deployable, easy and cheap to use. That's going to only accelerate. And finally, we're going to advocate for policy, right, using all the resources we have, counter attempts to shut down open source AI, and advocate for the open source AI as the way to collaborate on research and deployment. And the timeline, again, we're in a formative stage. So we have 75 members assembled. Everything is being built right now. If you're a member, you can get in touch and figure out how to contribute. We are standing all these work streams. And throughout the year, you will see the Alliance getting its voice. We'll sponsor AI.dev conference by Linux Foundation. We'll be present at all the major AI events. And hopefully, you will see the momentum throughout the year. So that's basically, so currently we only have this website, thealliance.ai. There is a form there to contact and express your interest. We'll also have individual membership. So if your company is not a member, right, you'll be able to join it individually if you work in an open source AI project. And currently, it's a very libertarian organization. We don't have fees, we don't have a legal structure. It's all going to emerge. So it's very new, like it's very exciting. We see huge energy unleashed by people getting together. It's more than a sum of its parts, right? Like it's almost like nuclear fusion. And for instance, when universities join, I've never seen this before, the universities join at the very top level, provost, dean of research, they send their top people, scientists are eager to take advantage of AI, right? And they need to get together with other scientists to figure out what AI is going to do for their sciences, right? And I think as much as everybody in industry, folks are having the same brainstorming in science. And I think in almost any other area of human endeavor. So that's kind of, the idea of this. And I think the main point here, community is the defining feature of AI. If you think it's pure technology, you don't see the actually driving force, right? Like if you question, how many people took Waymo here today, right? So if you take Waymo, you think it's a machine, right? It doesn't have any humans in it, right? It's AI, I think the leading artifact of AI. However, if you talk to people at Waymo, you understand there are thousands of engineers who spend thousands of hours. They drove millions of miles. They looked at their simulators. They didn't sleep because something hit something else, right? So eventually, behind every AI, there is a community of people who make it happen. So it's an easy mistake to think that AI is going to replace humans. Actually, any AI you see requires intense collaboration of humans, right? And especially if we have uncertainty where this is going to go, how do we verify its safety? This requires for more human collaboration, not less, because our traditional ways to ascertain what is true does not apply. Nobody knows, right? Objectively, this is what we know. Nobody knows exactly how to validate LLMs, how to ensure their safety. We have multiple approaches, and I'm sure you're going to see and hear a lot of talks following here today. But the main thing is that we're all here talking about it. This is the way technology is being built, right? And so we're at the heart of Silicon Valley, and convening a community like this is the best and only way to very quickly iterate on what we know as a human collective, right? And so we arrive at certain ways, and then we believe that this is the ways to develop the future. And so the Alliance is basically the home of this, right? So we're setting up structures of community to quickly validate ideas, test ideas, arrive at practical solutions. So again, very happy to connect more on this. I'm just Alexey, Alexy at IBM.com. Reach out to me. I run the Bay Area AI Meetup, which is the most established 10-year-old technical meetup in the Bay Area. We do monthly live meetings. And I'm really happy to connect. If you want to join the Alliance, discuss open source projects, we'll have ways to do this. So get in touch, leave your contact at that forum, at that website, and follow up the Alliance. Very happy to be here, guys. Thanks.
Is there something else, something you're trying to achieve? I'm not a believer. What I see is usually what I get. I'm not a believer.
Thank you very much, Alexey. Alexey and AI Alliance are sponsoring the after party tonight, Wednesday. So at 6 p.m., the event will conclude. After a break, we'll come back here at 8. Pro Pass holders, you have a ticket to the after party. So come join us at 8, and thank you, AI Alliance. What else? The schedule. If you missed the announcement earlier, the best way to access the schedule is look at your phone and bring up AIuserconference.com. You can sort by Developer Day, Main Stage, Workshop 3, available to all pass holders, and Workshops 1 and 2 are downstairs in the basement for Pro Pass holders. So those are my main announcements. If you're having a good time today, mention you're here on LinkedIn or any of your other socials, Twitter, we'd appreciate it. We're going to start the next talk on time, so we got about 5 minutes. We'll have Idan from GitHub, and I'll see you guys in about 5 minutes. Thanks very much.
They say sometimes some things just cannot be explained. I've been around. I know that nothing ever comes free. Just give it up, and you just might get the best of me. I'm not a believer. What I see is usually what I get.
Hey, one other announcement. So we have all the main stage talks up here, but we're not doing Q&A up here. So we have the full 20 minutes for the speakers to use. Q&A is going to occur over here on stage right. Remember Alexey from 2 minutes ago? There he is. He's right there. So if you have Q&A follow-up with any speakers today, just go see the speaker at the conclusion of their talk over here at that high top table. So please go see Alexey for any questions. Thanks.
Well, I used to be your man, and I was proud of it. Do anything you asked me to. But before I knew it, I supposed to do? But what would you say if she was going off with someone? Or what would you say if she was going? Whoa! Or what would you say if she was going off with someone? Or what would you say if she was going? He should be doing what I've done for you. Should be doing what I've done for you. He should be doing what I've done for you. Should be doing what I've done for you. I used to hope and pray that you would stay with me. Love is a fragile thing. But now it seems my hope for her was all for nothing. 'Cause you done found another man. So what would you say if she was gone out with someone? Or what would you say if she was gone? Whoa! Or what would you say if she was gone out with someone? Or what would you say if she was gone? He should be doing what I've done for you. Should be doing what I've done for you. Whoa! He should be doing what I've done for you. Should be doing what I've done for you. What I've done for you. Should be doing what I've done for you. Whoa, he should be doing what I've done for you. Should be doing what I've done for you.
Home, home. Baby, I'm home, I'm home, I'm home. No more lonely nights will you fear. No more lonely days will you ever be alone. No more lonely nights will you cry. No more lonely days will you have to wonder why. Oh, I'm home. Oh, home. Baby, I'm home. I'm home. I'm home. Ooh, baby. When the sun rises in the morning, upon my face you're gonna look. There'll be nothing but love, joy, and constellation. All these things you're gonna find in me.
Okay, I would like to introduce our next speaker. Very excited to welcome Idan Gazit. Idan is Senior Director of Research, GitHub Next, from GitHub. So let's welcome Idan.
Hello. Good morning. Have you all heard about AI? It's been in the news, just a little bit. Cool. Okay, so this famous photo, that one, was taken about 1970, right? And it shows Ken Thompson and Dennis Ritchie, and they're inventing Unix, right? There's probably a lot of their work in every device in this room. And they're doing it on a teletype machine, right? Which at the time was the best interface for writing software because what it replaced was punch cards, like holes punched into cards to record ones and zeros. And one card would be 80 columns wide, and you'd treat each card like a line of code. And you'd write your code first on paper, and then when you were happy with it, you'd have to like manually punch it into these cards one by one until eventually you had a program, right? A whole program. And you'd keep it in something like a shoebox, and you could write helpful notes for yourself on the side of chunks of it to describe what that logic does. Now, this photo of the teletype 50 years ago was not the dawn of software development. It was a huge upgrade because it was the first direct, low latency interface between programmers and computers. You could just type into the machine to create software, and the machine would type its output back to you. But you still had to author software line by line, right? The editors in the day of the teletype were actually line editors. You would ask it to print line 53, and then you would carefully craft the perfect edits to that line. And because each round trip with the computer consumed ink and paper, you wanted to be very intentional about what you were doing. You didn't just want to like mess around. And when we finally got CRT terminals, that cost disappeared overnight. But it took a while for editors to figure out what this new tech was good for. At first, they worked exactly like line editors, right? Except you could see more lines. So it was great, I could see more lines, but in the beginning I couldn't just cursor around anywhere inside the file wherever I wanted to. I couldn't make arbitrary edits wherever I wanted. You still had to go to line 53 and ask it to insert something at column 12. And as time went on, we figured out what was possible with the new technology that was not possible with the old. You could type anywhere you wanted and move around in a file. You could change the color of text in order to tell you if something is a variable or a function or whatever. Later on, we figured out that it's really nice when the editor completes your variable names for you. All this stuff was possible on the first day that the CRT existed, right? We just didn't know how to use this new tech. So we started out using it like the teletypes that came before it. And when graphical displays started to happen, we saw the same transition take place. In the beginning, IDEs were just screen editors inside a window, right? It took some time for us to figure out what this new tech wanted to be used for, right? Sidebars, hovers, red squiggles, annotations, jump to definition, indentation guides. It took time for us to discover all of these things. And even though AI isn't exactly a new display technology, I'd say that it's another one of these fundamental technological shifts. So just like the teletype, the CRT, and the graphical display, there's stuff that could exist with AI today, but we haven't discovered it yet. So now we're in this part of the cycle where we bolt this new tech onto the old tech, usually in the shape of chat interfaces, because it's relatively easy, right? And because the models are naturally good at the whole conversational prompt and response thing. So hello, my name's Idan, and I work on the future of developer tooling at GitHub on a research team called GitHub Next. We're the team that originally created Copilot and a whole bunch of stuff since then. Our job is to figure out how to make software development faster, safer, easier, more accessible for all developers. And last year, I gave a talk that looked backwards on the mechanisms that we've already found for building AI applications for developers. Copilot became a success for developers on the back of Ghost Text, and Chat helped popularize AI for literally everyone. But today, I'm going to be looking forward a bit and thinking about the kinds of things that we'll need to figure out in order to reach for tools that are AI native. One of the key problems with AI today is predictability, right? We're used to computers being perfectly consistent, right? 2 + 2 is always going to equal 4 no matter how many times you compute it. But the models are inherently non-deterministic. Every time we ask the models for something, we're pulling the handle on a slot machine. Now, the models are getting better, so in practice, the odds that our slot machine gives us something good are improving. But to date, we've only been playing the low-stakes slot machine because we're only asking them to generate a little bit, like a few lines of code, maybe a function. But if we try to ask the models for something bigger, like implement an entire feature or fix this bug for me, the chances that we get back something good become pretty slim. So effectively, there's a ceiling on suggestion size. Above it, it's like blackjack. You know, you go too far, you're going to get back hot garbage. And it's not to say that it's easy to reliably generate something good that is a line of code or a few lines, but generating an entire pull request is a very different kind of task. It's more code, but to implement a feature or fix a bug, you're probably going to need to touch files all over the code base, right? Not just the file that you're editing right now. Or maybe you're using your phone. There's no editor. There's no file I'm in right now. I can't actually use that as context. So yeah. And the kind of instructions that we want to be able to give the models are full of ambiguous natural language. And we don't want to have to tell the models where to look in the code base in order to get the job done. Even if the compute takes time, we want to be able to ask the computer, like, fix the bug, go eat lunch, come back, and there's a solution that happened with no supervision. That's the future, right? But the technology isn't there yet. If we want something that isn't a gamble, we still need to steer a little. If we're going to ask the human operator to supervise, how do we make it cheap and easy for the human and good for the model? Unfortunately, the request-response cycle is indivisible. It's a unit. You send out your prompt and you get something back. You can't steer anything in the middle. So there's only 2 real levers for us to pull. You can try to craft a better prompt before you send it, or you can chain a few round trips together and try to do something smart in between those round trips. And for the last few years, almost all the attention has been on the first lever, right? Prompt crafting. And so there's 1,000 blog posts about which incantations you have to utter in order to get the models to reliably cough up some useful response, and 1,000 strategies for choosing what information is most valuable to send to a model, because the context windows are so small. Even though they're growing all the time, they're still, like, you have to choose who gets to, like, stay on the island and who gets voted off. I don't believe that we're going to break the suggestion ceiling only using that first lever. Good prompts matter, and they're going to continue to matter, but there's only so much that we can accomplish in one round trip. Jumping straight from prompt to code was a viable strategy for generating a little bit. For larger scales, we have to find a way to steer, and so many round trips. Now, chat is excellent. It's an excellent modality for talking things over, and it's gotten better at retaining context across round trips. And there are some emerging UI patterns about how to move the code I'm working on into chat and how to move results of my chat back into code. But otherwise, chat has no predictable structure or process. So in the past few months, GitHub Next has been thinking a lot about how to use multiple round trips to create a steerable process. It doesn't start in any particular file. Instead, we're going to be doing sort of these multiple round trips, and the human can see and edit the intermediate thing that happens before every round trip. And if you happen to see the keynotes from GitHub Universe last November, this was teased as Copilot workspaces, and I'm going to sort of take you on a tour behind the scenes of how it works. It starts with a query, right? You ask the models to describe the current behavior of something. This phase alone can be multiple round trips. For example, I write a query and then I'm going to round trip once in order to figure out what parts of my code base are even relevant to this query, right? Which files might I want to include as context? That might be one round trip on its own. And then the second round trip will be, I'm going to send my query along with the chosen content. And the result is usually something like a bullet point list which describes the behavior that you asked about, that you queried. And this mirrors how developers work, right? Before you can alter a system, you have to identify all the places where that system is doing work and understand what work is being done there. So say I have a login flow for my website. Here it might say something like, when the user visits the login page, render the login form, and when they submit the login form, check the password, and if it's correct, then send them on their way, and if it's not correct, then show an error message, right? That might be the spec that I get back from a query that's just like, what's my authentication flow? But the spec itself is actually a great place to describe the changes that you want to make to how the system works. Say you want to implement and I forgot my password flow, right? You can edit that spec that's generated in place, not only to clarify to the models how it works right now, but also to describe how you want it to be. And so once you're happy with all the alterations to that spec, you submit it. So this is now like another round trip. And we come up with a plan to describe what needs to happen in order to make the change that you asked for. And this is now the second point of control for the user, because the plan itself is editable too. Maybe there's some edge case that the model didn't realize it would need to handle. Or maybe there's some other guidance that you want to be able to give which will help the model do a good job of giving you code that does what you expect. So by the time that we generate a diff, we've got a clear idea of the code we have to touch. The developers had a chance to steer both the description of what exists and what should exist, as well as the plan for how to make that happen. And if you think about it, this approach also generates exactly the kind of information that we would need in order to generate tests that verify that the desired behavior works the way that we expect it to. But on the flip side, if things are not going in the direction you want, if the model is giving you back something that's like, it's not quite right, you can go back a step and tweak it. You don't have to back out all the way and roll the dice from zero, because each step builds on the last one. So it's not just steerable, it's incremental. Now, it's not a guarantee that the result is going to be perfect, right? We're not expecting the models to just guess what we want with their psychic powers, and we're not having a theoretical discussion with them either. If we're looking to break through the suggestion ceiling, there's a Goldilocks pattern in the middle which enables the models to be actionable but still supervised so that you aren't creating like a hot mess for somebody to have to review later. Of course, it would be even better if we didn't need to do all of this steering, if we could just write a spec in English that describes an entire program and get a working app. We tried that too. The tech isn't really reliable enough yet to be a general purpose tool. We were able to get it to work in constrained scenarios. In the prototypes that we tried, we wrote a Hacker News reader app for mobile devices using React Native with one plain English spec file. We would edit the spec and the app rebuilds live. And this actually worked. And it feels like the future. And at the rate that the models are improving, this is probably closer to being reality than it seems from today. I mean, think about it. A year ago, chat was released. Look how much has happened in the past year. But it also feels a little uncomfortable, right? Because for as long as there have been computers, we've had to give them very precise instructions. And we've invented all these programming languages for expressing these very precise instructions. Why would we want a piece of software interfering in the middle of that? The truth is that developers who write in languages that are, even ones that are very close to the metal, are still relying on a piece of software that's translating what they're writing into something that runs. So I think that there's some discomfort now that's going to go away. Like when the cloud was new, everybody was concerned about renting a shared machine, and now banks run in the cloud, right? I develop mostly front-end things in JavaScript, and I have 29 tools that sit between me and the machine. They're transforming the code, they're interpreting the code, they're optimizing the code. The last time that I looked at the output of any compiler was when I was in college, and that was when dinosaurs roamed the earth. So adding one more transformation layer to the stack is not that far-fetched. Coding in natural language is coming. Not today, but soon. And if it works, it might encourage a shift to a more modular style of programming, where we have a tree of specifications which define the different subsystems in a larger piece of software. This is coming sooner than we think. I think this has some really interesting implications for how code editors are going to look in a few years. Looking forward, the space in which we write code isn't only going to be about tasks or even really entirely about code. One of the prototypes that we built a little while back was the Copilot CLI. Like, if I want to execute some command on the terminal and I don't remember all of the different options and flags, I type what I want the command to do, the model produces the command that I want, and it can even explain all those pesky flags for me. It's super handy. But there's no real reason that this interaction needs to be linear. What if it could happen side by side, in real time? I think the first time I saw like the closest cousin to this pattern, I saw in a fantastic app for the Mac called Solver. It's like a calculator app. You type your formulas in on one side, and it just live updates the results of the calculation on the other. Now, chat launched a year ago, and it chose to go with a linear chat over this sort of side-by-side UX. And that makes sense because most of the time when I'm using chat, I type a little bit, and the model responds with a lot, right? The responses are way longer. But that forces us, when we need to iterate, when we need to fix what was said, or if there's been some misunderstanding, to iterate through more conversation. Like if the model misunderstood me, I don't edit my previous thing in place. Instead, I have to add a new message to clarify the old one. Like, no, I was talking about Paris in Texas, not Paris in France. But using AI as a partner actually opens the door to making interfaces that let us express what we want in whatever way is best for us in the moment. Maybe we want to start by describing the behavior in natural language, or maybe we want to start by writing code. The AI translates one to the other live, so we can check that what comes out is what we expected, and we can refine in place on either side of this sort of magic mirror. Like I can type code, and I automatically see what the machine understands that code to be in English. Or I can edit then the English, and it's going to be reflected back into the code. I think this is a very powerful pattern, and a lot of the things that we're exploring are interfaces around this sort of pattern. When you hold all this stuff out at arm's length, it starts to look a little bit like Donald Knuth's dream of literate programming, where code comes with an equal amount of prose describing the code. And the rise of notebook-style programming, particularly in Python and sort of the data community, is contributing to this trend. But the reality is that writing documentation, even this kind of documentation, is work, right? What happens when we can have it for free? What happens not just when we can have it for free, but when you can assume that all of the code ever written in the world just comes with this kind of description always? What if it's not just natural language encode? What if I want to think about my code in the form of a block diagram, and I want to edit that diagram and have those changes be reflected back into code? Right now, we've been so focused on how AI helps us to write code, but AI is going to deliver an even larger change, in my opinion, to how we read and understand code. And that matters because when you actually think about the work of software development, reading code is a much bigger part of the job than writing code. I'll close with one more area that I think is important to the future of AI-native user experiences for software developers. In principle, this statement is true. I've probably seen every futuristic editor prototype that promised a revolution with like fancy graphics and like nodes and wires and like a visual whatever, but they've all remained prototypes. At the end of the day, when I'm building things, And everybody I've ever seen building things is still working in an editor. Monospaced letters on a grid is how all of us still experience code. I mean, mostly, right? Graphical editors have found a lot of ways to display more information next to the code, above the code, underneath the code, whatever. They've found a lot of ways to layer more information onto the code itself, more meaning. But the problem is that there's a limit to how much crap you can show before you overwhelm the human with potential information. Either way, though, the text on the grid is going to be there, right? That's definitely always going to be there. So one of the projects we did last year doesn't look like it has anything at all to do with AI or the future of software. We went and designed a special set of typefaces for code. It's 5 different fonts that look very different, but which have exactly the same metrics, so you can mix and match them together. If all we have are letters on a grid, how can we use those letters, not the color, not decorations around them, to layer more information onto code? We're already using the color, the weight, italics, underlines for syntax highlighting. So if we want to add more information, we need a more expressive set of letters to show on the grid, and so that's why we went on this adventure. What if we could use a more authoritative-looking face to denote authoritative documentation? What if we could tell those apart from the to-dos and comments that we write for ourselves throughout our code? We're all excited about real-time multiplayer coding experiences. What if I typed in my font and you type in your font, and we can tell each other's code apart as we're building things? What if the text coming from AI looked mechanical? What if I could turn on a filter that showed me what parts of my code were authored by humans and what wasn't? There are a lot of really great fonts for code out there, but none of them actually work with one another because they all have slightly different metrics, so they can't fit into the same grid. And that means that no editor has ever implemented these kinds of behaviors because there was never type to support these kinds of behaviors. So we've released these fonts, and you can download them and use any one of them today, but no editor supports these applications yet. I think the important lesson to take away here is that sometimes reaching for the native experiences, these AI native things, is not going to be about more AI. We're not going to get there by just doing AI, but harder. We're going to need to invent some practical stuff that give us the capabilities, that give us the tools we need to reach for the future. Just like these folks who had to invent a whole operating system to create the conditions we take for granted when we develop code. And it was exciting because they had this moment where they could just type to the computer and the computer typed back to them, just like today. Thank you very much.
Cause I'm so faded, finding all these different ways to level up the night, chasing every high. I'm gonna remember this for life. Oh, feels so good when you can say what you feel.
Thanks so much, Idan. So Q&A we're doing off stage after presentations. So if you'd like to follow up with Idan from GitHub, I recommend it. Idan will be at that high top table just over here, stage right. Also, just a quick announcement before we get started with our roundtable. If you have any questions about the schedule, the most up-to-date schedule is at aiuserconference.com, so check it out on your phone. You can sort by Developer Day, which would be today, main stage, workshop room 3, that's available to all pass holders, and then downstairs you have workshops 1 and 2. By the way, workshop 3 just over here, at 10 o'clock, Luca Antiga from Lightning AI is hosting a workshop starting in about 10 minutes, just over here. So that's workshop 3, just once again. Other activities, please visit our gracious sponsors, CodeRabbit, MongoDB, AirTrain, Canva, Cloudflare, Convex. On the other side, Lightning AI, UiPath, Simplified. So please say hello to our sponsors. We really appreciate their support. We're just going to do a quick set change here, setting up for a roundtable on how LLMs can bring automation to new heights. Stay tuned. Give us 1 minute. We'll set the stage.
Cause tomorrow it'll be over, but the glitter still so good when you can say what you feel. Honesty will reveal what's inside your mind. Whoa, pink and glitter bringing bodies closer. I can feel the love rush falling from the sky. This girl was always on my mind.
Okay, I hope you're as excited as I am for this roundtable discussion coming up. Topic is how LLMs can bring automation to new heights. We have 4 incredible panelists. We have Gargi from IBM, Reed from Zapier, George from UiPath, and hosting the roundtable we have Sinan Ozdemir. So please help me welcome them.
Good morning.
Go ahead.
Good morning, everyone. Please come up here, take a seat. All right. Hope everyone's having a wonderful San Francisco morning. Yes, it is usually like this around this time of year, so we appreciate you being here with us. As Jackson mentioned, my name is Sinan Ozdemir. I will be moderating this panel. I will be wrangling these AI animals into giving us some answers about how we are all using generative AI in our feature sets and our products. We're going to start with some quick introductions. We're going to go down this path, just give your name, your role at the company, and just a little bit about yourself. I'll go first. Like I said, my name is Sinan Ozdemir. I'm the founder and CTO of a company called Loop Genius. I've been working in generative AI for about 10 years, former lecturer of data science at Johns Hopkins, written a few books, and I'm excited to be here.
Awesome. Reed, product at Zapier, focused kind of across the company with AI. Started with our more R&D efforts with AI, and now working kind of with how we're enabling that within the core, as well as R&D.
Thank you. Gargi, product management for watsonx Orchestrate at IBM. Been in this AI world for over 15 years. George.
I'm George Roth. I am the AI evangelist at UiPath. And I came to UiPath through an acquisition, one of the first acquisition of a company which extensively used AI years ago.
Amazing. We're going to start with an easy question. What has been the biggest success story that you have all had with generative AI at your company?
So for us, number one, I'd say actually giving users the ability to use generative AI in their own automations. Right, for us, it's, for all of us, probably, there's using AI under the hood in terms of how we make building easier, and then giving users the ability to incorporate it into their own automations. So like when OpenAI first released some of the APIs, we had the DaVinci, like support for DaVinci, pour one out. And people really loved that. ChatGPT then came out, and then the whole category of AI apps on our platform became our fastest growing category ever. On the under the hood side, probably some of my favorite ones, there's something we call AI Zap Builder. You essentially give it natural language, and it gives you the outline of what your workflow will be. And that's been incredibly helpful for a lot of users.
Access and automation of your existing feature set. Makes a lot of sense. Gargi, how about you?
Yeah, awesome. So again, watsonx Orchestrate, it's a product that brings together generative AI for automation with a natural, intuitive, conversational interface. So my biggest experience of a wildly successful feature was while building an AI assistant. The AI assistant really helped us automate tasks, which means, pull your data from Salesforce, summarize using the large language model, put it out somewhere for a decision to be made. But at some point, we wanted an opinionated retrieval augmented generation. So this is a very, very common pattern in generative AI, where you ground your LLM with content. And we came up with an opinionated stack where the LLM was IBM's watsonx, but our experiments show that you could actually put in any retriever. So it could be your vector DB of choice, your chunking strategy, Elastic, or use our retriever. So I think creating that opinionated stack that allowed users to use a RAG pattern very simply in their flows really made it work for our customers.
So keeping users up to date with the latest and greatest RAG systems,
yes.
Bringing more access and more automation. So that makes a lot of sense as well.
Yeah.
George, how about you?
Yeah, I brought my context here, so to make sure I'm not hallucinating too much. So basically, we are a platform company. We have hopefully you will stop by, we can show our platform. We have multiple layers, discovery, development, and actually operations of the automations. For us, AI was always part of it. We call it invisible AI because in every layer, we have the AI helping both the development and also helps communication with the developers. And a big thing is to reduce the skills necessary, how we call it democratization of development of automations for the citizen developers. And generative AI is a huge tool for this. Another thing is basically we use Gen AI to validate different things that we identify with other AI techniques or other techniques. Usually if we can do it with Gen AI, we run it with Gen AI. If the two things match, that's a good proof that it's probably we are on the right result. We use extensively AI for testing, all the test generations from NLP. We have a whole autopilot program, which you can come in the afternoon at 4 o'clock. It's here, a presentation. Also stop by, we can show it to you. And the integration with multiple LLMs. We are an open platform, allowing the customer to mix and match LLMs in order to use the best one.
Okay, so developing with AI in mind from the very beginning. It sounds like it's embedded in pretty much everything that you do, which leads me very well to my next question, slightly harder. Now that we're all prototyping faster, iterating, experimenting faster with generative AI, inevitably there's going to be some feature set, some product that someone thought of, maybe prototype, got on the sprint board, but never made it to production. Give us one example of that happening at your company, and if you can, tell us a little bit about why it never made it all the way to production. We'll go in the same order.
Yeah. So when I boomeranged back to Zapier to work on this AI stuff, and when we were doing a lot of the initial R&D, one of the first things we ever tested was, we called it Zap Chat.
Okay.
All of our initial products were like Zap Blank. The goal of this one was to see how far we could get the model to do chain of thought reasoning. This was, keep in mind, late 2022, and to get it to basically build an entire workflow for a user using nothing but chat, just continuously chatting about what do you want to integrate with, what do you want to do, where should that data go, and continuously going. And that really did not succeed. I think we learned that, especially again back on DaVinci, it felt like a game of 20 questions that was easily stretching into a game of 75 questions.
Better known as prompt chaining.
Yes, yeah, exactly. It was prompt chaining. And so that one really never made it.
Okay.
But, as I'm sure everybody here has experienced, you MVP with something, you learn something from that, and that kind of continuously led to, and I was very proud that we just quickly shut down so many experiments in those days. It was really fun.
That makes sense. I think that pure chat interface can be really hard to productize and get in front of users and make it really successful. So you're not alone there, I promise you. Gargi, how about yourself?
Oh my God. So Reed's example is very, very close to mine, which failed. So
That's good.
Yeah, maybe there is a learning there. But if you remember what I said, what was successful was the RAG pattern, because we de-risked the LLM by content grounding it. In this feature that we had, it's also for the business users. It's really helping them reason. So expect a business user to come and say, I want you to build this automation for me that allows me to do this, that, and the other. And on the fly, an automation gets built for you. This was not de-risked like the RAG pattern, which means there was really no way to content ground it. We didn't have data. And because we didn't de-risk the persona, I think the sequencing, reasoning really didn't work out as we planned. But it's for the business user, we wanted to give them a little tool in chat that says, I want to do this, that, and the other, and it automatically makes it on the fly. So we took back a strategy. We created a builder persona where you can go and a little bit with low-code tools build it out. And that seems to be working. But I think the main reason or learning for me was that we didn't really de-risk the LLM feature.
Okay. And just to follow up really quickly, de-risking. And I think this is going to, I have another question about that. But I think I'm curious for everyone else as well is, are you de-risking from the model side or from the user side? Or are you thinking about it from both perspectives?
Both, right? For the first one, the RAG pattern, we de-risked from the model side by content grounding it in a knowledge base. But here, it wasn't a RAG pattern, right? So we had to de-risk it from the user side. So either getting implicit feedback, hey, it didn't really work, I put that feedback back into my model. I think that was not done.
Makes sense. George.
Yeah, I will start that I think everybody here, with no exception, we don't know what we don't know about AI. Because this is like such a technology, like black box and magical almost. I give you an example. We have our own private previews that many things didn't make the production yet because we cannot release it before it goes to the preview, insider programs, and if passes that, we will release. So we have stuff that we release. But I give you an example which tells you why you don't know what you don't know. We had an implementation which was using Azure OpenAI in Singapore. And everything was groovy. It was, if I recall, was a government entity there. And they were looking, and the compliance people from there came and they said, okay, this is so cool. Can you tell us where are the servers? I said, what servers? This is the Azure OpenAI. This is on the cloud. Microsoft has everywhere. We have a law. Geographically, the data cannot leave Singapore, which find out Microsoft doesn't have a data center in Singapore to support their cloud. So this was the stuff we didn't progress until we find a solution to be hosted in the territory of the country. So this is, you have to be very careful, and this is related to trustworthy governance and stuff. That's the biggest showstopper for this project, not the technology.
How far did you get before you learned that about Singapore?
It was a project which was started actually with our consulting team. We have a consulting team too, and the project was stopped actually because until they find out, because data cannot. It's not virtual cloud stuff, it's geography. You don't have a data center, you cannot move data from Singapore.
Yeah, so these answers are ranging all the way from user experience wasn't exactly where we wanted it to be, and it didn't quite make sense with how we were delivering the feature, to government regulations literally stopped us from moving forward with this project, even though we had already spent money getting it going. And I think that's going to be and everything in between, it sounds like. So I have one final question. This is probably the hardest question. Thank you for sharing all your failures. We all really appreciate it because everyone here fails. We all know that. I have probably failed even more than any of you put together. Don't worry. Last question, though. Without government regulations, without thinking about a lot of external factors that could kind of get in your way, how do you or your team, your company, how do you define success in specifically a generative AI feature? And how does that definition, how do you collect feedback to basically achieve that metric? How does that pipeline work for you all? Once again, same order.
Sweet. I'll use one that's probably more relevant to this audience. We have a feature called the AI code step generator. So in Zapier, you have the ability to add like a Python or JavaScript step into the middle of your workflow. We had seen that almost as soon as ChatGPT came out, the increase of usage of code steps simultaneously magically went up. And so we played around with a feature that lives in the product to help you take natural language into a code step by leveraging the data. And we iterated on that, but the way we were tracking success was doing things as simple as did we increase the amount of, we noticed as well in that time period, failure rates increased, probably because people were doing ChatGPT generated code. And so increasing success rates of the code that was being sent through those steps was a critical one. Secondly, adoption and keeping those features on, or keeping workflows on and running with those features in place was another critical one for us. And then lastly, just pure like, how do you collect that feedback? I think we did have the kind of like, I'm trying to remember if we do actually have that thumbs up, thumbs down thing and that sort of one.
Awesome.
We have that in like so many of our features. It is hard to keep track. But yeah, shout out to everybody who's in the middle of eval suite evaluations. That's always fun. But yeah, getting all
Okay.
that data together.
Yeah, I mean, right, yeah, user experience plus does this code compile and run without error?
Yeah.
And I imagine there's a lot of human evaluation that can get thrown in there as well. Gargi, how about yourself?
Yeah, so for every generative AI feature that we decide to put in or not, I'd say 4 things that we absolutely do. One is what Reed talked about, right? Making sure you have implicit and explicit feedback. Explicit is thumbs up, thumbs down. Implicit is abandoned flows, user never came back, said something nasty, right? So we have to have that baked in. But apart from that, there are 3 other things we look at. One is tooling. If I launch this feature, do my developers and designers who are going to be really using these features, do they have the accurate tools for prompting, for testing the models, for if they're in the business of tuning and training, like it depends on what your platform opens up, right? If your platform is opening up tuning and training, do I have the tools? Because prompting to me today is like, and you heard from GitHub, it's like an essay writing. Can I give you better tools to really control the prompts? So tooling for testing and model creation and prompt generation. And then toolings or solutions, because I don't know, all of you are users of GenAI. There's a lot that you have to do in orchestrating an output of an LLM, feeding it to an enterprise system, mapping, doing the mapping of data transformations, and then making it available for users, which is of value, right? So I think there's a whole orchestration layer that needs to be done. There's a beautiful paper from Microsoft and GitHub that talks about this orchestration and the needs for it. And then the final thing is lifecycle management of models, embeddings, your prompts, your libraries, everything that goes from software to being hard, but hard plus plus in GenAI is something that I wouldn't disregard when I put in an AI feature. So yeah.
Implicit, explicit feedback. I'll come back to that in just one moment. But George, please.
Yeah, I'll tell you 2 ways to do this, and I think this is it's an important way to test it for every company. The first one is the very hard way, the KPI. Look at the numbers, and because UiPath has AI everywhere, it's very hard how you measure. And then we have this model with AI units, which is like a AI currency, because we use AI everywhere. And you have this in the background. So you have a pool of AI, you buy AI currencies, and then you consume them. So for us to monitor the success of the AI is looking at the AI units. These are the sales guys, and these are the tough ones. So now I talk about the soft power. The soft power is very important. You cannot spread the technology and the usage of a new technology without going to the grassroots of the users. For us, because we are a B2B company, B2C is even simpler, but in B2B, we have a whole set of different type of interactions with the customers, with webinars. We have something called the Immersion Lab, which is in multiple places in the world, where we bring in new potential industries. Like I did recently one with ocean management. I had no clue what that means. And let the people, the grassroots, come out with new usages. So this is the way, as again, one is sales, look at the numbers, that's cool, that's the tough one. And the second one is go after the grassroots to make friends with your future developers, because they will be your best advisors.
Yes, so we are putting explicit feedback mechanisms in front of our users. Literally, thumbs up, thumbs down. Are you aware of what you're actually giving feedback on? We have implicit feedback along the way. Did you copy and paste this code? Did you subsequently say something really similar to the AI because you didn't like the first one? Putting these along the way of the path to catch where you might be not performing as well, but again, it requires a lot more human evaluation. And then there's a tale as old as time. How do you get your machine learning metrics to match with high-level sales, business-level KPIs? This has always been really challenging, but especially with generative AI, making that bridge can be even quite more frustrating. So yes, making that community between machine learning and AI engineers and sales and professional development folks is as important as ever. I want to thank each and every person on the stage for taking the time to talk with us through their successes, their not so successes, and how they define success. Thank you everybody here for taking a listen to what we have to say. And if you want to hear a little bit more, we will be on the side taking some questions. But I want to thank once more, let's give it up for Reed, Gargi, and George. Thank you.
Thank you.
Thank you.
Okay, thank you so much, Sinan, Gargi, George, Reed. Appreciate it very much. Our panelists will be just here, stage right. There's a high top table over there. If you guys have any questions for our panelists, any person who gives a talk will be available for Q&A just over here. So please follow up with them there. Super interesting discussion. Thanks very much. Also, George and UiPath have a booth just on the other side. While we're at it, just a quick orientation. This is clearly the main stage. If you pull up your itinerary on AIusergroup.com, you can sort by developer day today, main stage. You also have workshop room 3, which is right here. Lightning AI is there right now at 11 o'clock. Convex, you have to check your schedule to know for sure. Convex will be hosting a workshop there. While we're at it, I'd like to thank the rest of our sponsors. They all have booths here, so please visit the booths. CodeRabbit, MongoDB, AirTrain is here, Canva, Cloudflare, Convex, Lightning AI on the other side, UiPath, Simplified, and actually we also have AnyScale just in the back there, so please go see AnyScale as well. With that, we have our next speaker coming up in just 2 minutes. We're going to start on time for the sake of the live stream, so stand by. We'll announce in 30 seconds. All right, everyone. I hope you're as excited as I am. Please help me welcome Jeff Boudier, Product Director at Hugging Face. Let's say hello to Jeff.
Thank you, thank you, thank you. Hi, everyone. Welcome. What a beautiful venue. Before I start the talk and while people are filing in, let me start by asking you for a favor. I want to ask you for a favor, and the favor is to do a selfie with me where you do the hugging face. You know the hugging face? We're not just a name, we're an emoji, and it's that emoji. Yeah? Are you ready? Okay. 3, 2, 1. Awesome. Thank you. Thank you for playing along. Today I want to talk to you about how you can build your own AI using open source and Hugging Face. I want to tell you how, and I also want to tell you why. Oh yeah, clicker. I'll click the clicker. Thank you. Perfect. Beautiful clicker. Oh my God. Okay, so I'm going to go quite fast. If there are any questions about anything that I say, feel free to email me. I'm at jeff@hf.co. Well, let's get started. First of all, I want to give you some context about Hugging Face, the latest and greatest, and perhaps 6 things that you might not already know. And the first thing is our mission. Our mission is to democratize good machine learning. And we do this through open science, models like Bloom, Edifix, StarCoder. We do this through open source, libraries like transformers, diffusers. Everything that we do is community-driven, and everything that we do is built from ethics-first principles. And speaking of ethics-first principles, I want to start with that. Our approach to ethical AI is to provide the community with all the tools and best practices to implement ethical AI in your daily work. And a great resource out there for you, curated by our Society and Ethics team, is the page on hf.co/ethics, where you can find tools like to measure biases in data sets, where you can find guides to build charters for your own projects. Okay, number 3. Hugging Face today is one of the most prolific and popular open source developers. In fact, I checked yesterday, we're number 20 on the overall global leaderboard for organizations on GitHub, ranked by GitHub Stars. And most of you, I assume, know Hugging Face through our main libraries, transformers, which is how you can access all of the latest transformer models, or diffusers, how you can run stable diffusion. But there's a galaxy of open source tools for you to build your own AI, tools like Accelerate to distribute your workloads across multiple GPUs, tools like PEFT, which is how you can very efficiently fine-tune models, etc. So a lot of tools out there, and I'm only going to cover a few of them. Number 4, there are already today over 400,000 open and publicly accessible models on the Hugging Face Hub. We actually host over 1 million repositories. That's 1 million models, data sets, and AI applications that you can go and use. And these models cover any kind of machine learning. 3 years ago, transformers were really about natural language processing. How do you classify text? How do you summarize text? How do you generate text? And today, it covers every facet of machine learning. From audio, how to transcribe speech, to vision, how to recognize objects, to even domains like time series or biology and chemistry. Everything is on the Hugging Face Hub, and we have a very useful features for developers who want to get started, which is the tasks page. Instead of focusing on like which is the best model, like is Bird better than Roberta, Alberta, etc., you can really focus on what problem you want to solve using machine learning. Is it a summarization problem? Is it a speech recognition problem, etc.? Start with tasks at hf.co/tasks, and it will tell you everything that you need to know to build a prototype for this kind of machine learning problem. Okay, and number 6, so hundreds of thousands of models. All of this generates a lot of usage, and today there are over 10 million downloads happening every single day on Hugging Face by AI builders like you, accessing and using all of these great models. And by the way, these statistics are open source as well. So if you go to the space here within Hugging Face, Transformer Stats, you can find the latest for the past 30 days. All right, so these were just 6 things about Hugging Face that you might not already have known. Now I want to tell you about why you should build AI with open source. Like, okay, this is great. There's like all these libraries, there's all these models, these data sets. But why should I care? Why should I build with open source when I can just put my credit card in and use an API instead? So the first thing is that when you build your AI features and applications with open models, you're building technology that is future-proof. And here is just 3 months of progress on the Hugging Face Open Large Language Model leaderboard for some of the most used industry benchmark to see how good those models are. And you can see that just over 3 months, the pace of progress has been breathtaking. The open source community is incredibly engaged and incredibly efficient at improving, building upon each other's work to get ever better models. So if you start a project where you build upon, say, Llama 2, it's going to be very easy for you to pivot and use Mixtral instead. And then Llama 3 is going to come, and then you're going to be using Llama 3. So build with open source so that the technology that you build is something that is future-proof. The second thing is that one theme that the open source community is really, really active on is machine learning efficiency, meaning making it cheaper for you to run all these great models. And there's been so much innovation happening just over the last 6 months to make models run on smaller instances in the cloud, to make them run on your local machine, to make them run even on a smartphone. And here I have just 4 blog posts that are focused on text-to-image generation, so stable diffusion, and how you can run that really, really fast for really, really cheap, leveraging Inferentia on AWS, which is a custom accelerator, leveraging TPU on Google Cloud, which is a custom accelerator, or even run it on your laptop or on a phone with Core ML. So building with open source, you can build technology where you actually control the underlying costs. The third point, which is when you build with open models, when you build with open source your own AI, then you can host it yourself. And that's a big deal. Like if you're working at a company, like any company that has an IT department is probably going to want to host their own models. And the good news is that with open models and open source, it's really easy to do. In fact, we work with all the major clouds and platforms to make that easy for you. Of course, we have options on Hugging Face if you want to host your models dedicated with Hugging Face infrastructure, and I'll talk more about that. But we also build product experiences with Amazon Web Services, with Google Cloud, with Azure, Cloudflare, NVIDIA, IBM, Dell, to make it super easy for you guys to take those open models and host them yourself. Okay. Another reason you should build your AI with open source is because with open models, you can actually version control them. You can actually know which revision of the model you're using. You can actually build a feature that will use a model that is not going to change under your feet, which is what happens when you build upon an API. One day it works, the next day it doesn't. Thankfully, on the Hugging Face Hub, every single model is, under the hood, a GitHub repository, meaning that you have full access to its history. You know who made a change when, you know what that change can be. You can look at the difference in the files. If you're used to GitHub for building code, this is the equivalent for models and machine learning. So you have full visibility, full version control, whether those models are public or those models are private. And then one last point, why you should build your AI applications and features with open source is that these are models that you can trust because you can verify them, because you can look under the hood, because you can adapt them with your own data, right? There's a whole gradient of how open a release can be. It can be only available through API, or it can be gated, like Llama 2, where you need to ask access for it. Maybe you have also access to which training data sets the model was trained on. Maybe you can actually see the evaluation results from the model. On the most open end of the spectrum, like a good example is StarCoder, which is a model that comes from the open science collaboration BigCode, with Hugging Face, ServiceNow, and the open source community. And with BigCode, we're able to build a model where the model checkpoints are available, the training data set, the stack, is available, and we were even able to build from the ground up a consent-first mechanism so that GitHub developers can look for their username and see if they are part of the training data, can request to be out of the training data, and we update the data set accordingly. This is today sort of like the best practices, how you can build open models in a fully open way. And the result is that from this StarCoder model comes a whole galaxy, a whole ecosystem of models derived from it with slightly different training data. Maybe it's fine-tuned on SQL, etc. All right, so these were 5 reasons why you should use open source when building your own AI. It's features and apps that are future-proof. You're going to be able to switch the models to the latest and better model. It's applications where you can control your costs. It's applications where you host the models yourself. You can version control them. And you can trust and verify what's under the hood. OK, so that was why. But now, how do you go about it? I understand there's like hundreds of thousands of models on the Hugging Face hub. How do I go about this? So the first thing is, when you're looking at a problem you want to solve with machine learning, is to find a good candidate model to go about it. And last year was all about large language models, and so we can start with that. And when you go on Hugging Face, you will find thousands, not tens of thousands of models, of large language models for text generation. And ever since the initial release of Llama by Meta, there's been an explosion of large language models that are fully open. And you might know Llama, but maybe you don't know Mixtral. Maybe you don't know the Code Llama 70 billion model that just dropped from Meta yesterday. Maybe you don't know Microsoft's Phi 2, which is much smaller and efficient. Maybe you know Mistral, but you don't know Zephyr, which is like the boosted version of Mistral. All of those are available on a Hugging Face hub. And so when you think about open models for your AI projects, you have, either on one hand, a handful of proprietary models, or on the other hand, like a galaxy of models that have been fine-tuned for particular data, particular use case, particular languages, quantized for specific performance on specific instances, etc. And by the way, here on this slide, I have color-coded the models by license. And it's very important when you look at open models to consider which license is it being published under. And in blue are all the models which are being published under a commercially permissible license. You can use it to build commercial products. And the dark ones are the ones that are usually research purposes. OK, but now there's like thousands of open LLMs. Like, how do I go about this and find the one that's right for me? Well, we have a very popular tool on Hugging Face called the Open LLM Leaderboard. I don't have the URL here, but you can just Google it. The Open LLM Leaderboard is an application where we constantly evaluate all of these different models contributed to by the community for the most important benchmarks. And we have very easy to use filters. So you can filter for the licenses that you're interested in. So you can filter for the model size. So you can filter for the kind of models. Is it a pre-trained model, an instruction fine-tuned model, a chat model? And easily find the model that you need. OK, so now you have a model, and you want to work with it, you want to improve it, fine-tune it, you want to collaborate with your team about it. One thing that's not very known is that I talked about the million repositories on Hugging Face. Half of those repositories are private repositories. You don't see them when you go on the Hugging Face hub. And that's because the hub is how teams and companies want to collaborate together to build their own AI internally. And whenever you create a model or a data set or an application on Hugging Face, you can choose for it to be public or private. So today, the Hugging Face Hub is how the open source community collaborates in the open to create their own AI. And for companies that want to do the same thing internally, we have something called the Enterprise Hub, which is kind of like GitHub Enterprise for Hugging Face. And that's a great example. Writer AI, I don't know if you know them, they build amazing applications, and they're an Enterprise Hub customer to build their own models. They have great open models, by the way, Palmyra, amongst others. Okay, so you have a model and you started working with it with your team using the collaboration tools on Hugging Face. What's next? You want to deploy it. You want to deploy it in production in a way where you can control your costs and have great performances, meaning latency and throughput. And that's where our text generation inference solution comes into play. It's a code-accessible solution available as a container. You can deploy it. It's fully optimized to give you the best possible performance for large language models. It's implemented support for Llama 2, for Mistral, all the latest and greatest open models. And we also built specific optimizations so that if you're using an NVIDIA GPU, we can use the latest and greatest features. If you're using an AMD Instinct GPU, we also have native support for it for best throughput. If you're using a custom accelerator like AWS Inferentia, like Habana Gaudi, we have built specific support for that. So it's like your production solution for large language models. Okay, great. So now there's this solution, but I don't want to deal with infrastructure. How do I go about this? This is where Hugging Face inference endpoints come into play. Like the latest models, or actually any model that's on Hugging Face, is just a couple clicks away for you to turn that into an API you can consume in your applications. Just pick the cloud you want to deploy in for a particular model, the region, the kind of instance that you want to deploy it on, and you're good to go. And all you have to do, is to pick an instance. So if I take an example like the best model from Mistral right now that is topping the Open LLM leaderboard, that is over GPT 3.5 performances, that's Mixtral, a mixture of experts model with 7 billion experts. That model is just 2 clicks away. Here, picking Amazon Web Services on an A100, it fits on 2 GPUs. That's $13 an hour. You're good to go. So remember at the beginning, I was like, okay, so when you go about building your own AI features, applications, you can either put a credit card in and use an API, or build your own technology that you host, that you control, etc. Well, it turns out it's not that much harder, right? It's just a couple clicks to get Mixtral under infrastructure and an API. Cool, you have a large language model. How do users interact with it? Well, we have an application called Hugging Chat. It's available at hf.co/chat. And it has like all the best open LLMs available, deployed, and you can use it for free today. You can use Mixtral, you can use Falcon 180 billion, you can use Llama 2 70 billion, you can use CodeLlama. So really easy for you to get more familiar with these open LLMs. And what is not very well known is that the application itself is also open source. And you can find it on our GitHub. It's called Chat UI. And so using text generation inference in the back end, using Chat UI in the front end, you already have the contours of a full solution to build a chatbot. And there's a little cool button here. I don't know if it's a picture, but when you use Hugging Chat, you'll see that you can toggle web search on and off. And what this toggle does is it uses retrieval augmented generation to improve the context that the LLM gets when answering the user's question. And so how do I build this? How do I build retrieval augmented generation? So you already have an LLM, right? You picked it from the LLM leaderboard. You deployed it with text generation inference. Now what you need is another model, which is called an embeddings generation model, which is going to vectorize the user's question to try to find the most relevant information in your own database. And to do this, we have the little cousin of text generation inference. It's called text embeddings inference. It's a production solution for embeddings models. And just like with the Open LLM leaderboard, we have a great leaderboard for embeddings models called the MTEB leaderboard. So take the best embeddings model, put it under a text embeddings inference. You can use inference endpoints to not have to worry about infrastructure. And with Hugging Chat, you can now use retrieval augmented generation on your own company data. And again, like all this stuff is hosted in your own environment, right? So it's fully compliant, and your IT department and security officer is going to love you. Today is Developer Day at the User AI Conference, so I don't want to only talk to the Pythonistas in the room, I also want to talk to the front-end developers and the back-end developers, and I got great news for you. All the great stuff that I talked about is also available to you. So if you're building web applications, we have two great libraries for you. One is HuggingFace.js, which makes it easy to interact with models that are hosted on the hub directly within a browser. And then if you want to go one step further and actually run the model within the user's browsers, we have this great library called Transformers.js, where everything runs directly within the user's browser. So it's really, really cool. And then if you're a back-end developer and you're building everything with Rust, you'll be happy to know about Candle, which is our framework that is being built natively in Rust so that you can build machine learning from the ground up using Rust. All right. So I told you about how you can pick a great large language models, embeddings models, put it together into a retrieval augmented generation application. Great. So you built a great application. Congrats. Now you want to show it to the world. And that's where Spaces come into play. Spaces is a very easy way for you to host AI applications so you can show it to your users, you can show it to your customers, you can show it to your team. And there are tens of thousands of spaces on the web. So if you ever seen like on Twitter, like those funny images or these cool like portraits that are generated, usually they're generated using a space on Hugging Face. This one is illusion diffusion, where you put a mask in and the model is going to create, using diffusion, an image that uses it as a control net. And there are every kind of application. I told about all the different kinds of models. And we curate the most popular and trending spaces every week. So if you go to hf.co/spaces, you will see the most popular spaces at that particular week. All right, that was a lot, hopefully not overwhelming. My main message was to tell you that you can build your own AI, your own models that you can control, that you can host yourself using open source and Hugging Face. And if that is overwhelming and you need an extra hand, the good news is that we have a service for expert support. We help companies and guide them along their journey building with open source. So check that out on hf.co/support. All right, that was how to build your own AI with open source and Hugging Face. I hope I wasn't too fast. I think I could go even faster.
It actually is Hugging Face. It's a leading open platform for AI builders, democratizing good machine learning. But what does that actually mean? There are three pillars: models, datasets, and spaces. Models are the thing that actually do the AI. We host hundreds of thousands of models, including ones from major companies like Google, Microsoft, and Meta, as well as research institutions like Stanford and open source communities like Eleuther AI. Then there's datasets, openly accessible data, used to train the models. And finally, spaces, which let you easily demo and showcase models. A recent example being illusion diffusion. All of these pillars together are combined with open source libraries like Transformers, Diffusers, and Accelerate, making it easy to build, share, and use the latest AI models. All of this is free, but if you need more compute or help deploying your own models, we have that too. So if you want to be involved, go to hf.co.
Well, that was faster, and also with the acoustics, even harder to follow. Thank you so much. Have a great day.
Start to pick at the rips in my Nikes.
Thank you so much, Jeff from Hugging Face. Great presentation. If you have any questions for Jeff, as Jeff said, you can email him. But one other thing you can do is go see him over at that high top table for a Q&A follow-up. So we're doing Q&A off stage, if you haven't noticed, stage right. So Jeff's heading over there right now. If you'd like to go meet Jeff and ask him any questions, I think now's a good time. I think it's also important to point out that Jeff does have Hugging Face stickers. I've seen them, they look great. They're actually a little bit shiny. So if you're interested in a sticker, it's the best sticker I've seen in weeks. What else? Where are the bathrooms here? The biggest indoor bathroom in San Francisco and the cleanest is downstairs. So if you need to use the bathroom today, check that out. There's one up here too, but they're smaller units. So just want to point that out. Another announcement, if you check out your AIuserconference.com schedule, in workshop 3 at 11 o'clock, Michael Serb from Convex will be hosting a workshop that begins at 11 o'clock. And the topic will be streamlining AI app development with Convex for advanced integrations and real-time capabilities. So it'll be a super hands-on and useful developer workflow. And we're just gearing up for our next speaker. We'll begin momentarily.
Yeah, yeah, yeah. Da 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 da. Everything and sometimes, even you and me, my lady. I don't know when the bottom might fall out. It comes out you so fast, yeah. The only thing I know, I just wanna stay next to you. Oh, right next to you. Yeah, yeah. Yeah, yeah.
Everything is fine on bright days, yeah. When the rays are shining, baby. But if you feel the rain, boy, just call my name. I'm next to you, baby, yeah. Oh, next to you, baby. Next to you, baby. Da 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 da.
Developers, distinguished guests, please help me welcome our next speaker. We're very lucky to have Gur Singh, co-founder of CodeRabbit. Let's welcome Gur.
Thanks, Action. Hello, everyone. Where did everybody go? Come back, code reviews are important. So we're going to talk about code reviews and how CodeRabbit is using AI to transform the reviews. A little bit about our journey. We launched back in July. you have a nose and we are seeing another one. Need to flip it the other way, I think. Yeah. So I'll do it like this. Tama na, Kek. Tama na, Kek. Ikot, ikot, ikot. Sorry about that, guys. I think that's what happened. Thank you. Okay, so we'll talk about the code reviews and how CodeRabbit is using AI to transform them. About a little bit about CodeRabbit journey. We launched back in July 2023. For the first couple of months, we were fortunate to have our funnel of customers who helped us improve our product, refine it. And since then, we have been getting a pretty good adoption. Currently, CodeRabbit is in use at over 400 organizations. So let's talk about the current code review process. In terms of automation, we have linters, static code analyzers. These are good at enforcing coding styles, finding syntax errors, finding security vulnerabilities, looking for areas for performance optimizations. But what these really lack is a context-aware feedback based on the functionality, based on the intent of the code changes, based on the design patterns that the organization follows. And for these reasons, code reviews have largely been manual up until now. And if we look at the pipeline CI/CD, except the code reviews, everything else is pretty much automated. And the manual code reviews have their own challenges. It's a slow process. GitLab recently published the data where it says that a merge request on GitLab on average takes 2 to 4 days to be completed. And that slows down the developers, but along with that, it slows down the deliverables. It slows down any hot fixes that need to go out to production. There's a context switching that happens. A developer has created a pull request, and they move on to the next task. Depending on when they get the review feedback from the peers, they have to switch back, get back into the code, and it takes time and mental energy, and it slows down their productivity. And then we have dysfunctional teams. In many places, I guess we all being developers, we have seen that code reviews become a mere rubber stamping. There are personality clashes within the teams where the developers just cannot work well together. They get into nitpicking smaller issues, and that slows down the merge process even further. And this being a manual process, it's prone to errors. So there was a study published by SmartBear which shows that a human brain can process only about 400 to 500 lines of code in a single review session. So that means like there's a code which is getting shipped out to production, which is not effectively reviewed. And when we find the bugs in production, I guess we are all well aware how costly and how significantly complex they become. So what does CodeRabbit has to provide? It's an AI-powered code reviewer which does a context review feedback, which gets smarter, better over time. And in terms of the USP, it accelerates the code reviews. It does a pretty comprehensive review within about like 5 to 7 minutes, depending on the size of the pull request. And along with that, it finds the issues which are generally missed by the humans. So with the unique AI insights, it have people thinking on the way they have implemented the functionality and how it could be corrected. And this is the simplified version of how the reviewer works. We get the events from Git providers, GitHub, GitLab. Whenever a pull request is created, there's some pre-processing that happens. Part of the pre-processing, we gather additional context that's needed to do the reviews. It comes from the code repositories. It comes from the workflow systems. The teams might be using like Jira, Linear. We get additional context from the prior reviews that might have happened on those repositories. We use the prompt customization that has been done for those repositories. Using all that, we build the review request that's sent to large language models. We get a response back, suppress the noise that needs to be suppressed, and then it goes through a series of verification steps. And the reviewer autonomously decides if further review is needed. And this happens for each and every diff that's part of the pull request. So once this is completed, all said and done, the review is posted within GitHub. And there's a review state which is maintained on GitHub. The core features of the product, it does continuous reviews. When a pull request is created, the reviewer kicks in. It completes a review in about 5 minutes. And if there are additional commits which are made on the pull request, it does an incremental review of only those new commits. It does a pretty good first level validation against the linked issues. So generally, whenever a pull request is created, it's linked with some ticketing system, whether it's GitHub issues or Linear or Jira. So it goes in, it does that validation whether the pull request meets the intended need or not. It also identifies any related issues. And this is helpful in case if a developer forgets linking the issue with the PR. If there are duplicate issues within the repository, if it's like buggy, brittle code which is broken often, it would list out all the issues which were fixed around that piece of code in, let's say, like last 1 month. It does a line-by-line review of each and every diff within the PR. And if there are any actionable suggestions, those are posted as review comments. If there is a code change suggestion, that can be committed within the pull request with a single click. And then it does a verification across the entire code base for the changes in the PR. So let's say if within the pull request you have changed the code which is referenced anywhere else in the repository, if there's a function signature that is being changed. So it goes in and validates whether outside of that PR it has been updated or not, and if it's not, it flags that. And then you can have, you can chat with the bot, you can ask it questions, you can provide it more context, you can have it write the code, you can have it write the unit text, etc. And as you have these conversations with the bot, we parse those conversations and we generate the learnings out of those which are used for the future reviews. And over a period of time, this builds a team knowledge base across your code repositories, the way you style the code, like design patterns, standards that you use. Yeah, and another interesting feature with this, so we are having AI generate the shell scripts. So with that, in your natural language, you can essentially ask any questions about your code repositories. You can ask like who were the top contributors on this repo in, let's say, last 1 month. What are the issues which were closed in last 1 week? Which are the most frequently changed files? What are the number of lines of code that was changed? So next I wanted to touch on the AI stack for developers and how we envision it. So as developers start using AI like as a general knowledge base, like as the developers are in the design phase, they have more broader questions. They use AI chatbots like ChatGPT, Perplexity, etc. And then as the developers start writing the code, we have a GitHub Copilot, we have Cursor, we have a few more code generation tools. But all the code that is getting written, that needs to be reviewed as well. And irrespective of whether the code is being written by a human or by a bot, it still needs to be reviewed. And that's why we need a AI tool like CodeRabbit to review the code. So now we'll, I guess, jump into some of the review examples. The review takes about 5 minutes, so I'm not going to do a live demo, but I'll go over some of the existing reviews from open source. When CodeRabbit reviews the pull request, at a high level, it generates this summary. There are like 2 levels of summary. One is like kind of release notes, non-technical. And then there's a technical walkthrough where it shows like which files were changed and what were the changes in these files. And if we look at this specific pull request, it identified that there was this issue which it believes that got addressed with this PR. So most likely in this case, the developer forgot to link the PR. And if we look at the pull request again, after the review was done, the developer updated and added this comment that it fixes this issue. And then for the issues which are linked with the PR, it does this first level of validation for the objectives within the issue, whether those were addressed or not, with the confidence level, if it's not sure. And in this example, if we see there, the issue had objective that the documentation and the user guide needs to be updated. So most likely, maybe it's out of the scope of this pull request, but it was able to identify that these changes are not part of this PR. So this is an example of how the review comments are posted and how the conversations work. In this example, the bot commented that when this code is reading from the cache, it's not checking for the undefined for null exception. And the user responded back that this object would always be cached. It can never be null. And after that, the bot went and it checked wherever that cache is being set, whether over there it's handled or not. And it prompted the user that if that's the case, then you should probably fix when you're setting up the cache, which sure enough, the user agreed and they made the fix in this commit. and then the bot responded that, yeah, great to hear the issue has been resolved. And in this case, it's not the AI just being nice. It actually goes in and it validates whether within that commit that issue has been addressed or not. This is the example for how it generates the learnings. So the bot left a comment that a new parameter is missing a validation. The user responded that the validation is handled in this simulation file. And after that, it goes in and it checks whether it really is being handled in the simulation file or not. And for that, it uses the shell scripts. And once it has determined that it is handled in that file, it generates a learning out of that. So it says the user has clarified that the validation is handled in this file. So after this, in future, whenever the review happens, it has this additional context that where the validation is being handled. This is another example. The user changed the name of the function. And part of the review, it was able to go in and identify that this function, the older function, is still being used in one of the files and it needs to be updated. This is a similar example. I think we can skip it. Yeah, this is interesting. So the bot left a comment based on this to-do comment within the code. And it said that, like, do you want me to create an issue for it to be handled in future? And the user responded that sure. And then after that, bot created an issue within the GitHub repository. I guess the user was just trying to test whether it appended this text, which it did if we look at the issue. Yeah, this is another interesting example. So in this case, the user asked CodeRabbit to create a class diagram using a mermaid's syntax within the pull request. And which sure it did. And these kind of insights are exceptionally useful when, as a peer reviewer, you're looking at the code and you're not sure where exactly it's being referenced. So you can ask the bot any kind of questions around your code base. And I guess, yeah, I can keep going on, but like all these are on the public repository. So if you go to GitHub, you search for CodeRabbit, and it would show all the pull requests that have been reviewed by CodeRabbit. It's about, I think, 60 to 70,000. So the sign up is pretty simple with a GitHub or GitLab account. Within a few minutes, you have the app installed on the repository and it's up and running and it starts reviewing the new pull requests. You get a free trial for the entire organization for 1 week. And if it's open source project, then it remains free forever. That's all I had. Thanks, everyone.
When the dog keeps looking up, will you say me now? No one's around. Will you save yourself from falling down? Will you save me now? No one's around.
Thank you so much, Gur. Gur is at the CodeRabbit booth just over here. So if you have a Q&A, if you want to follow up with Gur for any Q&A, please go visit Gur at the CodeRabbit booth just over here. And with that, we have a great panel discussion coming up. I would like to introduce our panelists. We'll have Kasia, Staff Product Manager at GitHub. We'll have Anand Das, Co-founder and CTO at Bitto. We'll have Scott McVicker, Head of Developer Infrastructure and Corporate Technology at Stripe. And finally, Shubha Nabar, Founder and Chief Scientist at Pharos. Shubha will be moderating the panel as well. So this is very exciting. The title of the panel is Best Practices for Implementing AI Pair Programming Tools. So very interesting to find out how all this works in real life, in production. That's what we're here for. So without further delay, let's have our panelists join us on stage. Let's welcome them.
You wanna go middle?
Okay. In the middle.
All right, first of all, thanks everyone for braving the elements and the traffic to come here to learn all about AI pair programming tools. To give you a little bit of context on my background and my connection to the topic, I'm a co-founder at Pharos, and basically for the last 4 years, I've been working on building this data platform that hooks into every part of the software development lifecycle and gives visibility into velocity, quality, throughput, developer satisfaction, and so on. And so now as we see AI impacting every part of the software development lifecycle, like from writing code, to code reviews, to test automation, and so on, you're going to see the need for visibility a lot more, right? Because there's going to be shifting bottlenecks, downstream impacts, and so on that need to be measured. And so I'm deeply interested in this topic, and I'm very excited to have world-class experts in the field as our panelists today. So we have Anand from Bitto. Bitto's AI helps developers dramatically accelerate their impact. We have Kasia, a staff product manager leading growth for GitHub Enterprise Cloud, Copilot, and Advanced Security. And we have Scott, who leads developer infrastructure and corporate technology with an emphasis on integrating observability. Okay, so maybe to start off with, Kasia, since you're at the forefront of this really seismic shift that we're seeing happening right now, what are some of your interesting stories from the field? What are challenges that organizations are facing in adopting these tools? What are some of the success stories and so on?
Sure. Hi, everyone. One of the observations that we are seeing from the field is that a big component to innovation is to make developers feel empowered. And what does it mean? Empowering developers, pretty much making them work better, faster, efficient, and provide them in a flow and just overall happiness of developers' state of mind. And what we learned that actually AI tools like GitHub Copilot brings that efficiency, therefore brings the innovation to the product. And we ran this research where we learned that 92% of developers that are based in the US are already adopting and using some kind of AI tools into their programming, either like for personal or work. And through those tools like Copilot, they're actually seeing that innovation happening in the workspace and personal projects. So definitely AI plays a big role. In terms of the challenges of adopting AI per programming tools, I think it's the biggest problem is change management. Meaning that organizations and companies have a hard time in terms of understanding how that benefits the product and also how to use it properly. So at GitHub, we spend a lot of time with the field to do seminars, webinars, lunch and learns, and trying to bring a lot of data to the organizations and those leaders who are deciding to purchase GitHub Copilot. So I think that's the biggest challenge. And what we are seeing from success stories, so Indra, for example, it's a company who is providing product like Galileo, which is like the most precise satellite navigation system. And during COVID, they struggled with hiring top talent. So they decided to go for GitHub Copilot and to bring the innovation not only for their product, but at the same time, the tools that they are using. So they were able to actually bring that innovation, hire interesting developers and talented developers, and bring that satisfaction and into their product. So I guess that's what we are observing from the field.
For organizations that have adopted these tools, what percentage of all the code that's being written would you say is being generated by?
Yeah, so actually the numbers that we are seeing at GitHub is over 46% of the code at GitHub is generated with GitHub Copilot.
Yeah, it's pretty amazing. So I guess maybe as a sort of a follow-on to that, Scott, so when we work with organizations and we've helped them sort of A/B test different pair programming tools, what is your advice as someone who heads up the productivity and infrastructure function? What is some advice that you would give organizations on how should they compare their options and make decisions on whether to invest in this tool or that tool? And
yeah, great question. So honestly, I was a sort of AI skeptic. January last year, our CEO was really interested in sort of trying out Copilot. But I was a little apprehensive on what would it do to code quality, how helpful would it actually be, would it be able to measure it. So we started out quite simply with just a pilot. So we picked 200 engineers randomly across the organization, and we split them into 2 cohorts. Each week we would ask a different cohort what their experience was, and we just sort of set them loose on Copilot. I think one of the interesting things is it was month to month. So like the commitment wasn't for a whole year. It was really easy for us just to try out and see what the experience was. Initially, we had like a 2-month pilot sort of staged out that we were going to try. But the results were sort of so positive after the first 3 weeks that we just canceled the pilot and just rolled it out to everyone. So I think when the sort of sentiment questions we were asking was how often were you accepting changes, and it was sort of the standard Likert scale of always, most of the time, sometimes, hardly ever, and never. And the sort of 80% of people were accepting changes most of the time. So we sort of really realized the value it was adding for our engineering cohorts and engineering population. I think one of the unique things at Stripe is we have every single part of the engineer workflow instrumented. So every time they run like git pull, we know how long it took, what branch they were in, and sort of how long, how many refs they were pulling down from GitHub. We understand every time they run a linter, every time they run a unit test, every time they run a build step. So we're really able to sort of understand the sort of end-to-end experience that engineers have. And then the overall metric is branch to master. So from them creating the branch to getting it sort of merged into master, how long was that taking? And we saw with those that were using Copilot that they were faster than those that weren't. So we've been really excited about it. We just sort of tried it, and organic adoption really sort of helped. But yeah, not a very scientific approach, but one that really sort of worked.
But it sounds like you already have a lot of that measurement in place in Stripe to give you the confidence in going forward.
Yeah.
Anand, I think AI pair programming tools are just sort of the tip of the iceberg, right? There's going to be a lot more happening. Do you have, could you give us a sense of what's coming in the next 3 to 5 years?
Yeah, so if you kind of look out, 4 to 5 years, what we are seeing is, if you kind of look at developers, how they're using AI solutions today, is actually build automation for things that they are not able to do on a daily basis, but want to get done. One of the examples was CodeRabbit out here for, doing code review. So what we see is in the future, there will be an army of agents or tools, right, which developers, will use. And these tools will understand your organization, its data, your code, so that developers can unleash them to actually work on, organize, and manage tasks. And these tasks can be complete workflows or something that you can basically on an ad hoc basis, like generating test cases for which people don't have time, fixing code smells, which have been there for a couple of years, but you just don't have developers to actually put out there and manage it. So software development is going to transform, and we believe that the areas wherein you have resource crunch or you have a higher cycle time will be the areas wherein these tools will come up first. And these tools will then help developers focus more on what they need to do, critical thinking, architecture, design, because with Copilot you don't need to write code from scratch, but you have to verify, validate that you're kind of building something which satisfies the needs of the business. So that is where we'll see the future will be.
Got it. And I guess in terms of best practices and training for adopting this kind of tooling, what has been your experience in the field? Like when we deployed Copilot at Pharaohs, we were very informal. Do you recommend a certain approach to how companies roll this out? And are there certain teams that would benefit more from it, or what have your experiences been?
So I think it really depends on the size of the company and your objectives, but letting that product to be used by a specific team, like as an early adopter, and then educating other teams on how to use it, what are the best practices and so on. And I think like with any generative AI or LLMs, I think it takes time to figure out like, hey, what are the right prompts and so on. So having that rollout being, you can start with a small, or like in case of the Stripe, it was a big sample size, 200 people, right? So it really depends, but having engineers play with the technology, kind of understand it and use it, that's the best approach. And it really depends on, again, on the objective of the company, like what are the problems you're solving with it. So
I think one of the things, one of the teams we worked with found was that senior engineers seem to benefit more from these kinds of tools. And has that been your experience too?
Yeah, I think one of the things we noticed at Stripe was senior engineers knew what they were going to type, so they started typing it, and then Copilot pops up with like, would you like me to autocomplete this? So I think senior engineers found it a lot more intuitive because it was able to sort of complete their next thought. I think we found with like those earlier on in their career, they didn't really know what they were going to write, so didn't know how to give the initial prompt.
I see.
So I think they're going to be more interested in the sort of prompt base, like explaining what you want it to do, which I think is in Copilot X.
So do you see like the skills that developers are going to need? How do you see that changing with these kinds of tools?
So I think developers will need to get better at collaborating with AI tools. Let me put it that way, because it's generative AI, you ask questions, right? But if you don't ask right questions, you're not going to get right answers. So yeah, senior developers are able to use it better because they understand the business context, they understand the architecture, they know exactly what they want, and giving the precise instructions to actually get the desired outcome is a skill, and not everybody is able to communicate in that fashion. So if you kind of look at all the literature out there, people talk about prompt engineering, it's basically some people, get it easy of what to ask and how to phrase the question, whereas some people don't. But getting to know, these things will help developers. And also, the thing about what are the capabilities that these tools provide. Because, people, just think that, it's AI, I can ask it anything. But, it does have data that it has learned from. It cannot go beyond it and stuff like that. So they need to know the capabilities and limitations. And then all the other aspects, I think, that a software developer should have, those are required.
So it sounds like communication is, once again, very important. I think a lot of folks have curiosity about what is the quality of the suggestions that you get, right? And so does Copilot provide any metrics or insight into quality?
Yeah, so at GitHub we provide 2 telemetry APIs in terms of the activation, like have you assigned the license and when and so on, and how many people have pending invitation, and the usage, right? It's like, so what is the number of accepted suggestions and so on. In terms of the code quality, we at GitHub do a lot of research and try to understand what is a high quality code, right? Like what is the definition? And we developed those 5 metrics, meaning that is code readable, reusable, concise, maintainable, and resilient. And we run a study group where we ask developers to use GitHub Copilot and see how the quality code will improve with Copilot and Copilot Chat. And we actually saw a significant improvement in the code quality and also like the speed. So there's enough evidence that AI tools actually help developers with their code quality.
I guess what are some of the metrics that so as the scale of writing code and it's going to accelerate, what are the downstream impacts, and like what are some of the things that teams should be monitoring in terms of ensuring trustworthiness and reliability of the code that's getting shipped out there?
So I think one of the things we've seen is Copilot will copy-paste a lot of code, so it's not necessarily familiar with your own internal library helpers. So it will sort of reach back into either the common framework from the language or the common base framework the open source is based on, and it will try to sort of import suggestions for there. We've been holding it to the same bar that we do humans. So it goes through the same amount of tests, the same amount of linters, the same amount of X-ray checks against it. But I think one of the things that I'm really trying to keep track on is like the growth of the code base. Is it using well-known invariants that we have internally? So I think that's maybe an important thing to keep a track on. And I'm excited for custom models sort of built around your code base.
What's coming up, I guess? What is in the near, what are the new features that are coming up?
Yeah, so in February, we are releasing GitHub for Enterprises, where, as Scott said, you can do fine-tuning, and there will be more chat functionality overall. And what's next? Aiden, he was presenting earlier from GitHub Next. So I think a very exciting product that is coming out is GitHub Workspaces, where you can actually start your programming with like just GitHub issue. And personally, I think that we are at the beginning of the stage where actually right now it's just simple tasks and automations and efficiency, but eventually AI will be your second brain. Mm-hmm. So I think that's where we are heading and the direction that LLMs will take us.
I guess, yeah, so I guess going off of that, today we're in this position where the human's really driving it and AI is just the assistant. But do you see these roles reversing, and in what kind of time frame?
So, I'm not the Matrix Oracle, so I can't see the future. But in next, I'd say 3 to 4 years, not all the tasks, but where humans are driving and they don't need to be there. For example, I'm writing code and I don't have time to write test code. Can I actually use an AI agent or a tool which does it automatically, right? So those kind of changes are going to happen. But for that, we have to also look at the human sentiment and this behavior change. As we just talked about, like developers have to be responsible for the code that AI generates. There has to be a trust built by these AI tools. So if you're using a test code generator or if you're using a code review tool, you will first verify how these are working. Are these suggestions good? Is the code good? It's kind of taking care of code coverage and all those things. But once you believe, as you hire a new engineer, you train him, and then once you believe, you hand off the responsibility, the same thing will happen. Like some of these tools will start taking that responsibility. But humans will still be there in driving seat, configuring and providing guidance to these tools of how to evolve or what to do.
Yeah, that'll be a dream when you can just rely on them for migrations.
You'll need AGI for that.
So I think with that, we're wrapping up. At 5 p.m., we have a workshop on how to measure ROI, developer sentiment, and A/B test AI tools for software development. So please join us at 5 o'clock. I think it's going to be somewhere there. And thank you. Thank you so much for this discussion.
Thank you.
Really enjoyed that panel discussion. As Shubha mentioned, Pharos AI will be hosting a workshop at 5 o'clock. That's in workshop room 3, which is over there. If you want to find out what the most current agenda is, go to AIuserconference.com, click on agenda, sort by developer day today, and click on main stage for what's coming up here. Workshop 3, available to all, is right there. And downstairs is workshops 1 and 2, available to Pro Pass only. Beyond that, we'll also have the after party this evening. That's at approximately 8 p.m. right here. Pro Pass, you all have tickets to the after party. Other activities in the meantime include visiting sponsor booths. We have CodeRabbit, MongoDB, AirTrain AI, Canva. We have Cloudflare. We have Convex right there. We have AnyScale. Just on the other side, we have Lightning AI. Please go visit Lightning AI. We have UiPath, and we have Simplified. So a lot to do here. Please check out our sponsors. We really appreciate their support. And without further delay, I'm very excited to introduce our next speaker. Is everyone ready for this? Hype. Our next speaker is joining us all the way from the peninsula. Came a long way to be here, so I hope you guys appreciate. Okay, let's welcome Lucas Gonzalez, Product Manager, Google DeepMind.
Hello, hello. Testing, testing. Hey, can everybody hear me? Great, great. I appreciate you all being out here today to hear a little bit about Gemini Nano. My name is Lucas Gonzalez. I'm a product manager at Google DeepMind. My main focus at Google DeepMind is our small model family. And this model family is known as Gemini Nano. and you'll hear a lot about that today because that's what my talk will be covering. So first off, welcome to the Gemini era. Gemini models are a family of models developed by Google DeepMind. And starting from the top here, you have Gemini Ultra, which is our most performant, most complex model. It's really good for tasks that involve multi-step reasoning, math, coding, and science-based abilities. Then we have Gemini Pro in the middle. And Gemini Pro is what I like to call a sweet spot model, which allows it to be very, very fast, yet still remain highly performant across a variety of tasks. And then finally, we have the Gemini Nano family, which is what I'll be focusing on for this talk. Gemini Nano is our smallest, fastest, and most lightweight offering from the Gemini family. Within the Gemini Nano family, we further break it down into Gemini Nano 1 and Gemini Nano 2, and I'll be speaking about both. Why did we train such small models anyways? Well, the Gemini Nano model checkpoints were really created to push the limit of what a small, highly efficient model could achieve. How much knowledge, how much helpfulness can you pack into just a few billion parameters? We really do believe that Gemini Nano models are at the frontier of small, efficient models and at compressing so much knowledge into just a few billion parameters. Their relatively small sizing allows them to be deployed in places where even a 10B or 12B model would be too large. And examples of this would be on device for offline use cases, where nano models can actually run with absolutely no internet connection. And so, as I mentioned in the last slide, we train two sizes, which allows us to target a variety of devices. So some for devices with lower amounts of RAM and some for higher RAM devices that can kind of benefit from some additional parameters and increased quality. Cool. So now getting into some of the details. Nano models are built on transformer decoders with additional architectural improvements and some novel optimizations that we had as part of the Gemini family. Nano 1 specifically is a 1.8 billion parameter model. It supports a context window of up to 32K tokens, and it is distilled from our larger Gemini checkpoints. To keep Nano as small as possible, when we deploy it to target devices, we do 4-bit quantization of the model weights. And this makes a small model even smaller. On the chart on the right, you can see some of Nano's benchmarks. And so starting from the top there, we have famous MMLU, which is basically a multiple choice exam question answering pair from high school, college, professional level. It covers about 57 subjects from STEM, the humanities, social sciences, and more. It ranges in difficulty from elementary level to kind of advanced professional level, and it tests both the model's world knowledge and its problem-solving, multi-step reasoning abilities. Then we have TiDi-QA, which is about 200,000 question-answer pairs from about 11 different languages, and it explores a diverse range of linguistic phenomena and different kind of data challenges. Next, we have BoolQ, which is a question-answering data set, which is basically yes or no questions, about 16K examples, and these are natural questions like, is the post office and the Royal Mail the same? Is Thanksgiving always the last Thursday of the month? And the model then has to answer either yes or no to these questions. So you can see that we have particularly strong performance on TiDi-QA and BoolQ, which are kind of these natural text question answering benchmarks. Next, we have natural questions retrieved, which is a question answering data set where basically each example is comprised of a Google query and a corresponding Wikipedia page, and then the model is asked a question provided with this context, and the model then has to retrieve the context from the Wikipedia page and answer the question. And then finally, we have Big Bench Hard. Big Bench Hard is a diverse eval suite that focuses on tasks that are beyond the capabilities of current language models. So it's called Big Bench Hard because it's supposed to be really hard for language models. And we're actually really proud we were able to get these results with such a small model on what is supposed to be a data set that language models should really struggle with. So now moving on to Nano 2. Nano 2 is very similar to Nano 1. It's about just under twice as large from a total parameter count perspective. And as I mentioned earlier, it serves to improve quality for devices that have enough RAM to afford the additional size of the model. Now, looking at the same benchmarks that we saw on the prior slide, we see that Nano 2 improves across the board and performs particularly well on these natural text-based question answering tasks. We're also really proud about this model's strong performance on MMLU, achieving almost a 56 on MMLU, which is frankly one of the hardest benchmarks for small models alongside that Big Bench Hard benchmark I mentioned. And just to put it in perspective, this score on MMLU actually beats out Llama 2 7B, and it also beats out Llama 2 13B as well. So when you compare it to Llama 2 13B, which is also a text-only model, Nano 2 is about only 1/4 the total size in terms of parameters, yet it exceeds the Llama benchmarks for all of these benchmarks that you see here today. So again, we're really proud of the performance we were able to squeeze out of this model that has so few parameters compared to the large language models that we're used to today, and compared to some of the open source models that you would need in order to achieve these kind of results. But ultimately, raw benchmark scores can be a little bit hard to read and get a feel for how good the model is. So to kind of contextualize the performance of Gemini Nano, we can compare it to Gemini Pro. And so by normalizing Gemini Pro's benchmarks, meaning Pro's values would be all ones on this chart, we can see how the Nano models perform compared to it. And so this side is specifically looking at coding, math, and science learning tasks. And these are some of the more difficult tasks for small models to score highly in, honestly for all models to score highly in, as even the average human would likely score well below Gemini Pro's benchmark across these tasks. And so you could see for coding tasks, Nano 1 and Nano 2 perform about 0.3 to 0.4 as well as Pro. And then on MMLU, we see Nano 1 and Nano 2 perform about 0.6 to about 0.8 as well as Pro respectively. And so when you aggregate the performance along these much harder tasks, we can see that Gemini Nano is about half as good to maybe a little bit more than half as good as Gemini Pro is. So again, we're happy with these values. This is some of the harder tasks for models to do, especially for small models, which don't have that many weights to represent the complex multi-step reasoning that you need in order to do really well on these benchmarks. But it gets better. So now when we look at the same comparison, but for text question answering and retrieval tasks, we see that the Nano models actually perform about 70 to 80% as well as Gemini Pro. And Gemini Pro already has excellent performance at these tasks. So the fact that Nano is doing about 70 to 80% as well is really quite impressive across this benchmark suite. And so this really also starts to show where the strength of these small models lie, which again is really on these natural text Q&A based tasks, while we continue to iterate and build on those harder coding and math capabilities. So to contextualize it further, we can look at LMSys.org's Chatbot Arena. The Chatbot Arena is a side-by-side comparison tool where real human raters send a query, they get 2 model responses, and then they can pick between either of these 2 model responses, depending on which one they prefer. And from there, LMSys calculates an ELO score for each model. So this ELO score is based on actual human preference, not just on any benchmark. And so you can then use these ELO scores to compare different models to each other based on these real human preferences. So recently we submitted a BARD checkpoint powered by Gemini Pro, which you can see highlighted there in the yellow in the leaderboard. And that quickly rose to number 2 in the ARENA leaderboard. And again, this means based on real human preference, Gemini Pro is the second best model in the ARENA. And so as we showed in the prior slide, Gemini Nano models can do about as 70 to 80% as well as Gemini Pro on these text-based tasks. Therefore, this means that you can have a model running end-to-end privately on your phone, which performs 80% as well as the second highest ranked model that's out there today, according to human preference. You know, you could be in the middle of the jungle, you could be on Mars, and have in your pocket a highly competitive model that is representing a compressed form of all human knowledge. That's pretty incredible to me, and I think it's something that no one saw coming with this explosion of large language models. And frankly, that's why these like high value yet very small and efficient small language models are really quite interesting to me personally. So to kind of wrap things up on the text performance, we see that Nano shows some incredible capabilities, particularly on these question answering, retrieval task, factuality-based benchmarks. And for their size, they still do show relatively strong performance on these complex reasoning, math, and programming tasks. Performance that is above average human level for these tasks. But nano models, even though are small and already perform so well on these text tasks, can actually do more. Nano models are part of the Gemini family, and the Gemini family is inherently multimodal. So that means that nano models are also multimodal within that same parameter count as well. And specifically, nano models can ingest images and audio to do cross-modality understanding tasks. All of this while staying at these incredibly small sizes and already outperforming larger models that are text only and don't have these multimodal features like Llama 2 7B, Llama 2 13B, as I mentioned earlier. So now let's see how Nano performs on these multimodal tasks. So on this side, we can see how Nano performs across a variety of image tasks. And I think the titles of these image tasks are self-explanatory. But for the less obvious ones, MMMU up there is basically MMLU, but in image format. So it's basically college level subject knowledge, deliberate reasoning across art and design, business, science, health, medicine, humanities, social studies, tech, and engineering. So yeah, basically the image version of MMLU. Some of these other ones are pretty self-explanatory, like Chart QA shows the model an image of a chart and asks it a series of questions. Same with infographic, doc, and text VQAs. And then VQA V2 is a data set containing open-ended questions about images that require an understanding of vision, language, and also some common sense knowledge. So we could see that the state-of-the-art results are all held by Nano's big brother, which is Gemini Ultra. Gemini Nano is actually not too far behind when you compare it, because these results are not normalized, so you can compare those directly. It's performing on document question answering, reading and reasoning on text, and VQA V2 is really quite strong and very impressive when you consider the fact that these parameters are also shared across all that text performance as well. So the fact that these small models can correctly read infographics and chart about half the time, can correctly read charts and infographics about half the time, is also really impressive considering, again, such small models. Cool, so now we see the same thing, but for audio input here, comparing Nano 1 with Gemini Pro, with OpenAI's Whisper, which is a speech-to-text model. And so again, we could see a variety of different benchmarks. The top 4 there Lower score is better because that's the word error rate. So what % of words does the model get incorrect out of 100 words it transcribes? And in the bottom, the higher score is actually better. So I'm not going to go too into detail on these exactly what these benchmarks are. If you have questions, you could look them up, or if you have questions about them, I'll be at that podium in the right later and happy to chat about it. But basically, again, we see, of course, Nano is trailing its larger brothers and sisters, Gemini Pro and Ultra, but it is performing very close to them on this multimodal task. And notably, it is beating out one of our competitors' models that is built specifically to do this task. So to wrap up on multimodal, we saw that our Nano series of models can perform really quite impressively across a variety of broad image benchmarks while remaining extremely small in size relative to larger language models. And it's even better than some larger vision-only models for these vision tasks. Furthermore, Nano also exhibits very strong capabilities in speech-to-text, including in situations where audio translation is required as part of the benchmark suite. So some of those benchmarks that I showed in the prior slide are actually multilingual as well, and Gemini Nano can handle that too. So in conclusion, we see that our Nano series of models can perform about 50 to 80% as well as the larger model family across a variety of tasks, making it the ultimate value offering when it comes to small multimodal models. Its lightweight size allows for on-device deployment and very fast, high throughput, very efficient inference when hosted on the server side. And I personally think this unlocks a variety of really creative use cases and a great opportunity to scale the benefits of Gen AI broadly throughout humanity, which is certainly a challenge today with very large models, as we all know. And so I'd love to learn what kind of things people would be interested in building with this unique set of capabilities at this really accessible size. So I'd love if anybody, or if all of you can reach out to me directly. I'd love to hear from you. What are you trying to build? What do you want to see from these future iterations of these small models? What are you excited about with this model family? I'll have my socials on the next slide. Thank you all so much for your time and for hearing my presentation about Gemini Nano. All of the information you saw on the slides today is also viewable on our Gemini technical report, which we released in December. So if you didn't get pictures or you want to read about this more in depth, feel free to take a look at the Gemini technical report where these same details are shared as well. But yeah, thank you once again for listening to the talk. I'll be over at that podium for any Q&A after the talk. So thank you again.
Thank you so much, Lucas. Lucas is just going to get his mic removed, and Lucas will be over there at that high top table for any follow-up questions momentarily. So if you want to follow up with Q&A, Lucas will be right over there. We're doing Q&A off stage today because we want to focus on presentations on the main stage. Q&A is just in this setting here on stage right. So that's the process. We have our next speaker in about 4 minutes. In the meantime, just a few announcements on the topic of orientation. In case you haven't noticed, this is the main stage right here. The most up-to-date information on the agenda is at aiuserconference.com, so just jump into that website and hit agenda. You can sort by, of course, Developer Day, which is today, Wednesday, and then main stage for content here. Workshop room 3 is right there. So that's workshop room 3. In fact, in 9 minutes, we have CodeRabbit hosting a workshop here, hosted by Gur. And you can learn about automated code review, making code review a lot easier. You can also visit sponsor booths. We have CodeRabbit, MongoDB, AirTrain, we have Canva, we have Cloudflare, we have Convex. On the other side, don't miss Lightning AI, UiPath, Simplified, and in the very back, we also have AnyScale. In fact, our next speaker will be from AnyScale. I'll introduce our next speaker soon. Back to the agenda, workshop 1 and 2 are downstairs. Pro Pass holders, you can access those. Also, 8 p.m. tonight, we're having an after party here. This is an after party for all 3 days. This is sponsored by AI Alliance. So if you happen to see a guy named Alexi around, you can thank him for the sponsorship of the after party. So be here at 8 p.m. for that. There are bathrooms over here, a few. The biggest indoor and cleanest bathroom in San Francisco is downstairs. So Pro Pass and GA Pass holders, anyone, all are welcome. That's downstairs. Second floor, Pro Pass, check that out. We'll have pizza served on the second floor until about 1 p.m. So grab some pizza. I'll see you in about 1 minute to announce our next speaker.
No need to be upset, girl. You just don't understand. This is my conquering song. Laid on a wave so strong. Put the broke down.
Hello, everyone. Let's get excited. We got Matt Connor here, product manager at Anyscale. Please help me welcome Matt.
Thank you. I'm Matt Connor, one of the product leaders at Anyscale. I'm looking forward to talking with you all about how we're making AI infrastructure headaches disappear in 2024. Now, before I launch in on how we're doing that, I'd like to talk about the types of applications we're seeing developers building, the sort of challenges they're running into, and what's causing those headaches. So let's start with a real-world AI challenge, creating a patient assistant to help diabetics better manage their health condition. Now, managing diabetes is incredibly challenging. There's tens of millions of patients out there that struggle to keep their blood glucose in a narrow, acceptable range. This is made incredibly hard by the number of different factors that impact their glucose, like the food they eat, the dose they took, the type of medication they took. Just getting that right is hard, but knowing what happened previously that can help them iterate and improve their care is really hard. After all, how many of us know exactly what they ate 2 weeks ago and know how to modify and get better going forward? Now, tech promises huge advancements to help diabetics better manage their condition. There's new monitors that track glucose in near real time. There's systems that help log the medication and dosage that patients take. The mobile phones are now collecting context on where a patient was, what they did, what they read, what browsing they did that day, or what text messages they may have sent. Smartwatches are collecting health data and biometric data, and really exciting new developments with smart glasses and wearables are helping patients take pictures of the food that they actually eat. And so when developers look at a problem like this, there's a number of really exciting opportunities to help these sorts of patients. First, giving patients perfect memory and information. So if a patient asks a question like, what happened the last time I went to dinner on Friday at In-N-Out Burger, they can get the answer and make adjustments. Or if they want to ask a question, what's the healthiest item for me to eat at Olive Garden? They can get that information right in their hands and have better control over their condition. The second component of an application a developer might want to build is to be able to predict and alert patients ahead of time that they might actually be engaging in behavior that can cause their blood glucose to go out of control. And finally, the third component of an application like this would be to actually provide recommendations. Personalized medical recommendations for these patients to do a better job managing their condition, or tailored messaging to help them do a better job. Now, this is really exciting and very, very promising. But when you take a look at the AI infrastructure headaches that each of these components cause, you'll see why Anyscale exists and why we're working with developers to solve those. So let's go piece by piece. On that first part, on giving patients a way to interact and ask questions about their health and what might have happened last time they did something, this is a classic RAG application. And some of the challenges we see here are actually performing large-scale embeddings. If you have millions of patients and millions or tens of millions of documents, actually performing the computational task to create those embeddings can be very expensive. Evaluating the application that you built can be very hard. Knowing which model, which embedding model, which LLM, the chunk size to use are all really hard challenges, computationally expensive, and can cost you a lot in compute. Not fun things for developers to spend time looking into. Then we get to actually LLM inference. We all know about the size of LLMs and how hard it is to do inference and how cost prohibitive that can be. And so having the right infrastructure in place to lower costs is incredibly important. Actually getting compute can be really hard. These are very scarce resources, so having the right availability to build this sort of application and being able to put the right models on the right hardware. We just had an awesome conversation on smaller models, and being able to deploy those on the right instances is really, really hard. There's also the challenge of spiky traffic. In an application like the one we just described, you might see many patients logging in at dinner time, causing a huge burst that you need to scale and meet, whereas overnight there might be no traffic. And then of course there's reliability. Health is a 24/7 endeavor. You need to build a robust system that is always up and reliable. When we look at the second component, actually predicting and alerting patients ahead of time, some of the challenges here are, and I hesitate to even call it this, are traditional AI problems. Creating a training set and doing feature engineering with multimodal data can be incredibly challenging. Trying to create a personalized model for each patient when you have thousands or millions of patients necessitates many model training and distributed training, which can be really, really hard to do right. On top of that, if you're using a different type of model and maybe not using an LLM for this sort of task, being able to optimize the hardware is really hard. What I mean by that is these models might not need an entire large compute instance. They might need a fraction of the resources available there. How do we make sure that we can support that to lower costs in building this sort of application? And when we look at the last piece, actually providing recommendations, there's any number of challenges that come up. Some patients might have a rules-based patient approach, and we need to look up in a database the recommendation, return that to the user. Do we build that in an entirely different system? How do we orchestrate that alongside the model that actually sends the recommendation? We might want to do fine-tuning at very large scale. How do we manage that? How do we do that? And then we might want structured outputs. When we give these recommendations, we want to make sure that we track and learn from them. So while it's great that we give a patient a recommendation on a dose and a medication to take, we might want to capture that so that we can learn and iterate as we go along. How do we solve that challenge? And these are challenges that, while specific to this example, we're hearing over and over again, and they're only getting worse. And what I mean by that is that there's obviously been a huge explosion in the number of open source LLMs and models in general. We're seeing applications that are making use of where previously it was a handful of models, there's now dozens or hundreds of models, and that's only going to continue accelerating. After all, we hear about a new LLM almost every week. How do we incorporate that, fine-tune, and deploy it? Then there's the challenge that's common to these sorts of applications on just the complexity of AI infrastructure and how much that has grown in the past several months. When you take a look, if I had stood on this stage 2 years ago and mentioned that we were using a GPU, the conversation would have ended. Now it's which GPU? What tensor parallelism? Are you using Inferentia chips? What about TPUs, Gaudi, and so on? And so there's more choices than ever that developers need to be aware of. The second explosion has been in the number of cloud providers and compute providers. There's obviously the major cloud providers, but new cloud providers like Oracle and Lambda Labs further complicate choices for developers trying to build these sorts of applications. There's more frameworks and techniques. No longer is it just PyTorch or TensorFlow, it's what inference engine do I use? Do I use VLLM, TGI, NVIDIA RTLLM? Which one is right for my application? And finally, there's been an explosion in data, both the types of data being used, whether that's image, text, audio, speech, and the volume of data that are now powering these sorts of applications. All told, trying to stitch together these elements is hard enough, never mind optimizing to actually deliver your application with the very best price and performance that you can. And this is what we've been hearing from some of our very large users and developers that we work with. They're trying to find how do we get the most out of our compute resources and are future-proof in using the very best that's available to build the amazing applications we want to build. So we've been engaging with customers like Uber, OpenAI, who trained GPT with Ray, Samsara, and more that are all trying to solve this challenge. How do we build amazing applications and solve the infrastructure complexity issues? And that's where AnyScale comes in. We've built a platform to help build these sort of applications and make it easy for developers to focus on the actual application they're building. So I'll walk through a couple components of that application and the headaches and challenges they're addressing. First, as part of the platform, there's our serverless LLM API. We mentioned the prohibitive costs and compute needs to even start experimenting with an application. Well, the Serverless LLM API provides a dream playground for developers to get access to the best open source models with an OpenAI compatible API for a very cost-effective price point at $1 per million tokens. Out of the box, this helps developers start iterating, experimenting, and building the sort of application we talked about at the beginning. But there's more to it than just focusing on cost or providing compute. We mentioned that as part of this sort of application, we wanted to make sure that we provided structured outputs. When we make a recommendation to a patient, we wanted to have a known set of data that we can use to then continue iterating and improving. And that's what we call JSON mode, a new feature that we released recently that makes sure the response you get from an LLM is formatted to fit a specific schema. Super helpful for apps that integrate and work with each other, or for the example I highlighted on making sure we store that data and can keep learning rather than the randomness that might come with an LLM. The second piece that's super critical in the application example I provided is what we call function calling. If I ask a question like, what's the healthiest food to eat at Olive Garden, unless Llama 2 and GPT-4 were trained with that sort of information, it might not be able to answer. So providing an LLM the tool and an API to go and get the list of items on the menu at Olive Garden and the nutritional info enables me to build an application very easily for patients to get that sort of information and make adjustments. Now, as we talked about that initial application that we were building, on top of cost and compute, we started talking about some of the other pieces. Spiky traffic, optimizing your application for your very specific requirements, and more. And that's where AnyScale's self-hosted LLM offering comes into play. This offering gives developers the privacy, control, and customizability they need to address challenges like auto-scaling, spiky traffic, reliability, and more. And I'll highlight a couple features in here that help alleviate those problems and headaches. First is the ability to completely customize your setup. That means being able to deploy any model in any LLM. And after all, if you're fine-tuning, you might have thousands of new models you need to be able to deploy. There might be a new LLM you want to deploy, and you can do that with the self-hosting option. Secondly is being able to configure choices like the underlying hardware that's being used, the tensor parallelism, or accelerator. Certain models may work best on certain hardware configurations. Having the control and customizability to do that can help reduce compute costs while still meeting your application requirements. The next piece we talked about was reliability. Healthcare is a 24/7 issue. We can't have a system that's not robust and reliable. So out of the box, when self-hosting LLMs with AnyScale, there's integrated real-time alerting, there's fault tolerance and the ability to withstand node failures, zero downtime upgrades to keep your production application running reliably. In chaos testing, we've seen greater than 99.9% reliability, which is obviously very important for these mission-critical applications. Talking about some of the challenges with scaling and spiky traffic. Out of the box, when self-hosting LLMs with AnyScale, you're able to deploy models on shared resources and actually independently scale models, including all the way down to zero. So if we have an application with millions of users, if certain models are very lightly used, we will scale down and save on compute costs. And as we scale up, there's quite a bit of work that we've done to scale up very quickly so that your underlying infrastructure meets exactly the traffic that your application is serving. This helps make sure you're not having unnecessary spend and make sure that there's no surprise bills or sticker shock. Continuing on the thread of auto-scaling and cost, out of the box, automatically searching across availability zones for capacity, including on-demand and spot nodes. This means as you're serving your application, AnyScale is automatically trying to find the best price performance to meet the requirements. Obviously, spot instances can offer market savings over on-demand instances, and AnyScale can seamlessly transition between spot and on-demand so that your application's running as cost-effectively as possible. Now, in the early example we gave, we obviously had a very generative AI-focused application, a RAG application, to let patients chat. But there were other more traditional AI machine learning concepts that could help that application. A classification model to predict if a patient's about to make a poor decision. And so as you go beyond LLMs, Anyscale provides a developer platform with tooling that they love to help solve any AI workload, whether doing data processing, machine learning trading, or serving any type of model. One of the key features there is what we call Anyscale workspaces. Anyscale workspaces enable developers to work in familiar tooling like JupyterLab or VS Code, build, observe the applications they're building, distributed debugging to make sure they work right, and a seamless path to production. So as you move along in this spectrum and the types of applications we're seeing, tooling to meet every step. Now all this is made possible by our foundation, which is built on Ray, the distributed open source framework that has become an AI standard. Part of the reason it's become that standard is its Python first approach, its simple, flexible, and extensible API, the scalability, and its native support for heterogeneous hardware, allowing you to make sure that you're right-sizing your workloads on the right instances. Ray comes out of the box with a number of high-level libraries that make it very easy for developers to use and integrate seamlessly with the AI ecosystem. So whether you want to use TensorFlow, PyTorch, or name your framework, you are future-proofed and ready to go. To give you just a very quick example, it's as easy as adding a decorator to a function, and now things will be distributed. That same decorator, you can specify the GPU or accelerator to use, and now you're having complete control over your setup to optimize it for your workload. To give you a concrete example, let's take a look at a batch inference workload. So we talked early on about doing large-scale embeddings, and that's a type of batch inference use case. As part of that, we want to load some data. We might want to pre-process it, actually perform the embedding or do inference, and then save those results. With Anyscale and Ray, you can actually do this all with one framework and make use of different compute options at each stage. That has enormous benefits. If you're processing, let's say, 1 million images, with Ray, that can cost as low as $3.50. Whereas with a leading open source framework, it's more than twice that. And with one of the leading commercial ML platforms, it's 16 times that. So the flexibility of the foundation make it possible to build these sorts of applications and run them cost effectively. With Anyscale, that's improved even further by 28%, bringing the cost down to as low as $2.50. So there you have it. I think there's, the key takeaway is that the sort of applications we're seeing are incredibly complex. They're making use of all sorts of heterogeneous hardware to meet very specific requirements. Anyscale and Ray provide the foundation to make it possible to very fine-grained control over those elements to build and deliver these sorts of applications. Let's talk really quickly. I know as part of the talk we wanted to just highlight a couple items on our roadmap that we're excited about. First is what we call the Smart Instance Manager, or SIM. This dynamically optimizes the price performance of all your available compute resources to run your applications at the very best cost point possible. And as we're seeing an increasing explosion, as I mentioned, in accelerators, clouds, and choices, SIM is super important as it does all of the work for developers, so they don't need to focus on that piece. The second exciting opportunity I want to call out is machine pools. We've seen more and more clouds and on-premise deployments. Being able to create hybrid clusters that span across clouds and burst as necessary is a great way for developers to make sure they're getting the very best utilization of their very precious and sometimes expensive compute resources. So with that, I'd like to wrap up. Really excited about what we're building and the types of applications that we're seeing our developers and users engage with. And the only thing standing in their way is some of these really hard infrastructure problems. And here at Anyscale, we're working on supporting developers to deploy any model, any accelerator, and on any cloud. We have a booth in the back, happy to take questions back there, or I'll step to the side here after. But thank you very much, and have a great rest of the day.
Okay. So, Matt from Anyscale will be just over here at, actually Matt's making his way to the booth. Anyscale has a booth just against the far back wall, so if you have any follow-up questions for Matt, please go see him there. And we're right on time to introduce our next speaker. Please help me welcome Emmanuel Tourlet. Emmanuel is the founder and CEO of AirTrain AI, and we're going to learn about LLM evaluation. So please help me welcome Emmanuel.
Thank you, thank you. 1, 2, 1, 2, can you hear me? All right, does this work? Let me check. It does work. All right, hi everybody, my name is Emmanuel. I'm the founder of a company called AirTrain.ai. We have a booth over there. You can try our free playground. You can interact with different models. I'm going to show you how it works today. So today I want to talk about the process of looking at those various LLMs that are out there. So as you all know, at this time, GPT-4 is still the undisputed king of models. It performs the best on almost all tasks. It's the first model to try when you're trying to prototype an AI product. They always say, if it doesn't work with GPT-4, you can just forget about it, okay? So it is definitely the best place to start when you're trying to prototype an AI product. But it's not all perfect. Yes, it's great, but it's also very slow. If you take this data from artificialanalysis.ai, you will see that GPT-4 is actually pretty slow compared to other alternatives out there. It's also very expensive. GPT-4 is the most expensive model on the market. So it makes it a very good model for prototyping, see if your idea even works in the first place. But as soon as your idea works and you build out your product and you start scaling out, you start getting more users onto your application, you're going to have a huge bill to pay to OpenAI at the end of the month. So obviously that's not ideal. On the other hand, as you've heard today multiple times, small models can perform very well. This was proven last year by Microsoft with this paper called Textbooks Are All You Need. This was the Phi-1 model. Phi-1 is a very small model, a couple of billion parameters. Essentially, they generated some very high quality data sets using GPT 3.5 to do synthetic data generation, and also scrape the internet for textbook quality data. And so they have this very small model, about 1.3 billion parameters, very high quality data set, synthetic data, and they fine-tune the model on this data, and the performance is on par with the best in class. At the very bottom here, you have Phi-1, and you can see the results on the human eval coding benchmark. And the only two models that are beating Phi-1 are GPT-4 and WizardCoder. All the other ones, even though they're bigger models, do not beat Phi-1. So the point I'm trying to make here is if you take a small model, fine-tune it on a very high quality data set for a specific use case, you can have performance that is on par with large models. Another example is the Tiny Models paper that came out in April last year. This is a more extreme use case because the models are even smaller. If you look at the model sizes in the header row there, it's counted in millions of parameters, so very small, and the reference model is the 1.5 billion GPT-2 model. What they did is that they generated a high quality data set of stories for children and fine-tuned very small models on that, and then got the model to complete stories. And it turns out small models perform better than GPT-2. So again, small models, when fine-tuned on high quality data sets, can bring performance on par with large models. So how, as an industry, as a community, how do we get away from GPT-4? GPT-4 has its place, it's your prototyping model, but how do we get away from it? Well, the first step is to start with evaluation. You have to explore the other options out there. So there are two practices that are common when you do evaluation. The first one is called the vibe check, where you're just getting a sense of how those other models perform. So you just want to prompt them manually. Maybe you have a set of a dozen prompts that you usually try on those models to get a sense at a high level of how those models perform. Once you have this high level sense, this intuition that you've built, you need to move on to batch evaluation. Batch evaluation is when you create a batch evaluation data set of a few hundred or a few thousand examples, and you run them all through the model to have some statistical significance about this. Intuition is great, but intuition is not statistically significant. So once you've built your intuition, you need to move on to batch evaluation. So I'm going to quickly show you how you can do those things with AirTrain. So the first thing I want to show you is the AirTrain Playground. You can try it for free over there at the AirTrain AI booth. This is a free product. You can actually sign up right now and use it for free. You can put up together a number of models, some open source ones, some proprietary ones, and you can prompt those models at once and see how they perform. In this case, I asked those models to write a very short message to welcome attendees to the AI user conference in San Francisco. And as you can see, all the models return some reasonable outputs. Okay, that gives me a vibe check. Those models are reasonable, they're coherent, they can speak English correctly. Let's move on now. So how do they do on reasoning? Are they able to think complex problems? This is a common riddle that is used to try to make LLM fail. Here's the riddle. Julie is a girl. Julie has 3 brothers. Each brother has 2 sisters. How many sisters does Julie have? For us humans, this is pretty easy to figure out. Julie has 1 sister. It's pretty straightforward. Turns out, most models cannot figure this out. Even the best models here, GPT-4, get it wrong. Julie has no other sisters. Even though when you read the answer, it seems like the model has understood the problem, but gets the wrong answer. So all those models get it wrong. Okay, so what can we do to get it right? Well, there is one common practice in prompt engineering, and that's chain of thought. So you're basically asking the model to explain their reasoning. So this is the same prompt, but I'm adding this green component to it. Please explain your reasoning step by step. So obviously the responses are longer because the models need to explain all those reasoning. But now you can see that Mistral Medium and GPT-4 actually get it right. Okay, I can see that now some of those models actually get it right, are doing a good job at reasoning, but I had to add this, chain of thought prompt to it. So another example is arithmetic. Something that is fairly easy for us to do as humans may not be as easy to do for a model. So here I'm comparing 3 small models. I have Llama 7B on the left, Mistral 7B in the middle, and Phi 2, which is a 3B model in the middle. As you can see, all of them fail. None of them get it right. Okay, well, that's kind of disappointing. Let's see how the big models do at it. So here I'm comparing Llama 2 70B, so the big variant of Llama, Mistral Medium, GPT-4, and Gemini Pro. They all get it right. Okay, so that tells me something. It tells me that if I care about arithmetics, then maybe those bigger models do best than the small ones, or I'm going to have to do some work on those small models. So this is the concept of the vibe check. You get a quick sense of how they do. Here's an example on JSON extraction. So I am passing a news article, like a CNN news article, and I'm asking the models to extract 3 highlights and format them as a JSON payload. So you can see the response for all of them, and you can see that Llama 2 doesn't even get the highlight extraction correct. It's actually wrong. It's just giving me a number of words from the model. And then Phi 2 also doesn't get the highlight extraction correctly. It doesn't even get the JSON payload right. And then OpenAI, okay, gets the highlight extraction right. The JSON payload is right. However, I asked the model a specific output with back quotes to make it stylable, and then only Gemini gets it right. So here it is. This is our vibe check with various tasks that we're interested in, arithmetic, reasoning, and it's up to you to figure out what matters to you and prompt those models. So now that I have this general sense of how those models perform, the right scientific thing to do is to prompt those models at scale. So send similar prompts in large amounts to those models to have some statistical significance. So we have at AirTrain this batch evaluation product that lets you do just that. You can upload a data set of thousands and thousands of inputs, and then you can configure multiple models to prompt those inputs, and then you can grade the outputs of those models. So you have to score the output of those models. At this time, the best way to evaluate the performance of various LLMs on specific tasks is to get another model, a scoring model, to evaluate those outputs. It's called LLM as a judge. So essentially you use another model to score the outputs. So here we're going to evaluate a number of models, again on the same riddle, the sister riddle. And what I want to test is whether those models are consistent. We saw that Mistral Medium and GPT-4 got this riddle correctly. Do they get it correctly every time? If I ask the same questions 100 times, are they always going to give me the right answer? Because, models are stochastic creatures. They don't always give you the same answer for the same question. So here, I'm going to prompt those models 100 times with the same riddles. And the way that I'm going to evaluate if they're correct is I'm going to ask my scoring model. Here, the score represents the number of sisters that Julie has according to the chatbot. And here, I provide a rubric to help the model score the output. And then, so a score of 1 means that the chatbot said that Julie has 1 sister, score of 2 sisters, and so on. So now let's take a look at the results. So here, bottom left, you can see the definition of the score, and you can see the plot here. So if you remember, a score of 1 means that the chatbot has evaluated that Julie has only 1 sister, so that's the correct answer, and all the other answers are incorrect. So here I can see that GPT-4, again, is the best one here. GPT-4 has almost 100%. Almost 100% of the time when I prompted GPT-4 with this riddle, got the answer correctly. Not 100% though. You can see that, you don't have the number here, but this point is not exactly 100%. So sometimes GPT-4 will get it wrong. And then you can see that Mistral Medium is also mostly correct, probably around something like 88%. So 88% of the time, Mistral Medium will get it right, sometimes will get it wrong. And then Llama 270B is just flat out wrong all the time. So this is what you need to do to evaluate models at scale. Having your vibe check is important to build your own intuition, but eventually you need to throw hundreds, if not thousands of input data at those models to get a statistically significant sense of how those models perform. Okay, so you can get started for free with those 3 products. This playground is free for you to use. Just sign up now and then get started. Batch evaluation is also free. We also offer fine-tuning so that you can start refining those smaller models to perform as well as those bigger models. So get started now for free. We also have a YouTube channel where we produce weekly content about AI news, tutorials on how to get started with certain models. So subscribe now to our YouTube channel. And with this, thank you very much. I'll be hosting a workshop at 3 p.m. this afternoon to show you how to do this this kind of vibe check and batch evaluation. This thing's going to be in that room over there. And we have our booth right there, so come say hello. And thank you so much.
If anyone would like to follow up with Emmanuel Tourlet, AirTrain has a booth just over here. So if anyone wants to talk more about LLM evaluation, that is the spot. Also, Emmanuel will be hosting a hands-on workshop. If you want to go into more detail, that'll be at 3 p.m. in workshop room 3, right over here. At 1 o'clock, we'll have Craig Dennis from Cloudflare in workshop 3 as well. So keep an eye on that. You're good. If you want the most up-to-date information on the schedule, go to aiuserconference.com, click on agenda. You can sort by developer day, main stage, workshop 3, workshops 1 and 2 downstairs. So check that out for the most up-to-date agenda. We'll have our next speaker here on the main stage in about 10 minutes. We'll have Stuart from Quiet AI. In the meantime, go explore the building. At 8 o'clock tonight, Pro Pass holders, we're having the after party for all 3 days of the conference here at the Hibernia. So be there at 8 o'clock for that. Okay. Quick announcement. At 1 p.m., we have Craig Dennis from Cloudflare in workshop room 3. So keep an eye out for that workshop. That begins at 1 p.m. Without further delay, I would like to introduce our next speaker. I hope everyone's not tired from lunch. If everyone could say, "Hey, Stuart." Hey, Stuart. Yes, okay. Help me welcome Stuart McClure, CEO of Quiet AI.
All right, happy post-lunch coma. Thank you guys for sticking in. I'm going to go ahead and get started here. So once again, my name is Stuart McClure. I've spent the last 35 years really attacking code. But I started my career in writing code and building code, probably the first third of my career. And of course, back then it was really simple. I mean, you either knew it or you didn't, and you had to figure it out quick with very few resources. So we are today in a totally different revolution. And to tell you my journey real quickly, so started in cybersecurity, and I've hacked just about any device known to man, anything that's crawled, walked, or run. And I've spent a lot of it on stages just like this, doing live demonstrations of hacks. Now, I won't do that to you guys. I don't have as much time as I'd like. But typically, I'll actually ask for a volunteer, have them come up on board, and I would hack their device, given their approval, of course, right on stage. Now, don't worry, y'all look nervous like I'm going to do that. Don't worry. But what I do want to talk about is how every single one of those attacks, every single hack that I've ever performed, all come down to code. It begins and it ends with code. And that's where my journey really came into with Quiet AI. So Quiet used to be a company called Shift Left. If you've heard of that concept, right, it's the idea that we need to take cyber and security as far left into the cycle as we possibly can, because it's the easiest to fix there. It's much harder to fix at the far right when you're breaking into it on stage and figuring out, well, which line of code is that problem. So we are masters, if you will, of finding those vulnerabilities inside a code. And what happened when I started to work with Shift Left is I realized, wow, we could apply AI specifically into Quiet and how they evaluate code, which is truly unique in the industry. So all of you are now probably neck deep in trying to get some sort of code generation LLM to work for you. And if you haven't yet, you probably will shortly after the show. This is not going to go away anytime soon. We've now opened this Pandora's box. The genie's out of the bottle. We're not going to stop doing this. So what I'm trying to make sure I educate as best I can is to show you where the limits are and where the blind spots are so that you can be aware when you engage these generative machines, you know where to look for the common flaws and problems that occur. So this is just simple Copilot, but you probably all have tried to engage with some sort of other generative model out there. And what you're finding is, yeah, you can code a lot faster, and a lot of people are writing a lot more code. But what that tells me is all of those generative machine learning models out there are absolutely built on insecure code. So as you ask the models to generate certain types of code, you're going to get the same vulnerabilities that were created in the code originally when the models were built, when those transforms were built. So it's really important to know and just remind yourself, the only thing you're getting out of a generative model is what was put in. And what was put in was inherently insecure code. So I'm going to talk a little bit about that. Now, you've probably seen a few of these models, maybe not all of them. You should definitely explore all the code-centric models that are out there today. Some are better at some languages, others are better at others. But none of them, not a single one of these, have taken security at the very beginning and ensured that the data that it's building the model on is actually preventative of cyber attack. So what you're doing is you're carrying all three categories of attacks into the code that you're generating in the model. So the three categories of attacks, first is execution-based attacks. These are things like buffer overflows. You probably hear about this, controlling the variables and what happens and taking attacker input, making sure that you control that variable and that input to not allow it to do anything that the attacker wanted. That's the first category. The second is identity-based attacks. These are attacks that leverage others' identity. It's stealing an API key, it's stealing a token, it's stealing your username, password, it's brute forcing it, whatever. And then third is denial of service attacks. And these are just taking advantage of normal everyday functions inside of listening services or apps and exploiting them far beyond what they were ever expecting to bring them down. Now there is one other class of attack that we see primarily in apps, software applications. It sort of covers all three. It's what we call business logic flaws. And what we're going to talk about with business logic flaws is a whole nother sort of realm of what not to do with code. Now, if you haven't, really start looking into who's tracking on security in the code generation models that we're getting right now, because there are a select few early adventurers that are taking code, really going line by line to see where the vulnerabilities are in the code, and then just going back and asking things like ChatGPT or GPT-4 or you name it, hey, this is not secure, how can I make it secure? And it does not do it at all. Like, there are very, very few recommendations that are positive for you to contribute back into your code from a secure perspective. So take a look at some of the folks out there, like Low Level Learning. For example, Decode Bytes has a great article. Please don't use GPT for security guidance. I think that's more of a headline. I would say start with GPT, asking it for security guidance, but please, please do not use that as the definitive source. What you'll find is it might get you to that first step, but you're going to struggle to get second, third, and fourth iteration in for code security. So the attack landscape of code, if you've never seen or sort of delved into it, this is an easy sort of slide to understand. On the left is the data in to a model and the model itself. So are you polluting that model with data that is uncontrolled, that perhaps is controlled by an adversary or modifiable by an adversary? You have to, every single time you're dealing with some sort of LLM, generative, or any model for that matter, predictive or language learning, whatever, you really want to understand where is that coming from. Can we manipulate? I don't know if anybody goes to Vegas and watches, goes to Black Hat or DEF CON. But DEF CON is a famous hacker conference, and last year they pen tested ChatGPT and got their own instance of it and got it to actually cough up the credentials of the box itself because it had been trained on all of the materials on the system itself. And it did it by what they called mean girling it, which is telling them that someone was going to beat them up or hurt them if they didn't disclose those credentials. So the data, where how you train your models and how you implement those models is really important from a cybersecurity perspective, because me as an adversary can get into any of those, potentially. But then on the right side, it really is the outward-facing expressions of the models. So once you implement a model or once you start to generate code from that model, now you're really talking about the functions, the variable handlings, the library inclusions, things of that nature that need to be regularly tuned and evaluated for those security flaws. And it's so simple to miss some of the easiest of vulnerabilities, especially when you rely on automatic code generation systems. And what we're finding is a number of vendors are saying that they can do it all. They can allow you to create code, they can allow you to find the vulnerabilities, and they can allow you to fix. And I think that's a bit of a recipe for disaster right now. I really do recommend that we all take a look at each one of those elements and bring in the tools that are best in that space to deliver on the best results for each of these. So from code generation, vulnerability discovery, as well as fixing. Because each one of these is a very specialized field that a lot of people try to get into without much knowledge and firsthand experience. All right, so what we really need to build, I think, into AppSec is AI. I really believe it is the only way that we can get to a place where we can auto-generate secure code and make it stand the test of time. But you have to think about whenever you build code and you're getting code from a model, you have to think of it in these 5 factors, really. So there are known vulnerabilities that everybody knows about, right? There's a CVE or a CWE that's associated with a vulnerability, and you want to find those, for sure. But you need to find the unknown unknowns. These are the vulnerabilities that have yet to be found. They've yet to be discovered. That even a full class of vulnerability, a brand new one, could be coming out anytime. And you need to find these vulnerabilities before the adversaries do. So having a model and a predictive model to find the unknown unknowns in your code. Then you need to think about business logic flaws. Now this is an easy one. It seems complex because you're actually looking for the logic of your application and then finding some flaw in the logic of it, but there are simple examples of it. A great one is a hacker went into a McDonald's that had a kiosk. The software built on the kiosk allowed you to do maximum numbers of patties and cheese slices and lettuce toppings. Well, McDonald's had marketed that if you ordered from the kiosk and the order wasn't ready in 10 minutes, it was free. So you can see how a hacker would have gone in and said, well, we're just maximizing everything. And of course, there was no way they could deliver that order in 10 minutes, so he got a $300 order for free. And it went viral on YouTube, and it was fun to watch. But at the end of the day, that's a great example of a business logic flaw. Like, who as a developer thought, well, geez, these poor servers and cooks are never going to be able to match this time that the marketing team is saying that they can do. So there's that disconnect that an adversary or bad guy can take full advantage of. And there's far more complex ones, but that's just a simple one. But there's also specific rules within your company, within your teams, about how to address security vulnerabilities that may or may not be consistent with how these LLMs are getting built. So that distinction is really important, and to call out those specifics and ensure that you can train your own LLM on those specific fixes. It's one of the most important parts. And then lastly is the concept of auto-fixing. So we're building a lot of code, we're creating a lot of software around it, but we're not auto-fixing this stuff. And I do believe there's a space and a place for us to insert ourselves into that code generation process to automatically fix based on the elements before it. So the coding standards inside your organization or team, the business logic flaws that are common inside of these applications, and then known and unknown vulnerabilities. So whenever we build cybersecurity inside a code, we think of it as a risk framework. You can never get rid of 100% of defects. You can never get rid of 100% of security flaws. So the goal is to find out where is your measure of tolerance. How much are you willing to put up with? How much risk? Once that is defined by your team or your company, then a lot of this can work itself out. We can do a risk assessment based on that risk model. We can do a threat modeling. Threat modeling is where we come in and take a look at all of your applications, and we give you a scope, a threat-centric view scope of your apps. And we try to get you to design the application from the very beginning based on those threat modeling exercises. But at the end of the day, risk governance might be all that you can do, which is, hey, the powers that be in your organizations are telling you got to be NIST compliant, or you got to be something compliant. You can just put the context of security inside of that compliance mandate and deliver on code to that. And then lastly, of course, vulnerability testing using AI. I do believe this is going to be commonplace. Today it's quite unique and not many people are doing it. But that's where quiet AI really comes and shines. So the legacy technique for finding flaws and fixing them is really, really slow. It's really high false positive rate. I don't know how many of you have been victimized by a cybersecurity code scanning tool, and I apologize for that, but you'll often as developers get exhausted by all of these findings, most of which are completely phantom. They don't really exist. They look like they exist. Well, look, it's all fancy writing, and oh yeah, this looks really bad, parade of horribles of what's going to happen. But in the end of the day, it's just, let's say, a finding of a library that you instantiate, but you never call the vulnerable function. So it's not reachable. So what do you care? This is where you have to have the context around the finding. And really no one in the industry does this well. We thrive at this. You have to create that why. Why is this a vulnerability? Developers are not trained on security, so they're not going to really, you're going to see it right away. But walking them through, not just why the context, but why it's at a real risk to the organization, I think is really important. And of course, the traditional method, the legacy method, is you can only find what you know about today. So if you know that there's a type of vulnerability like a SQL injection or a buffer overflow, well then sure, you can go look in code for that. But what about the vulnerability that is not mapped out yet, discovered, mapped out? So that's where really AI is going to come into play. So we at Quiet have built predictive models on detecting known and unknown vulnerabilities in code today. And we've had that out for about a year now. And we're going to continue to expand more and more. And our target is fixed on providing an auto-fix, auto-suggest capability inside of our product. So as a developer, and you're in your CI and you see the vulnerabilities, you have the option of a fix recommendation with the natural button of, yep, let's fix it. So this will allow you to get the context of the vulnerability, but also be able to detect those unknown vulnerabilities as well. So just to finish out, you really, I think, would go well to help the organization as they instantiate and use these models to extend these models, build it more specifically to you, to your code, to your coding standards, to how you go about and run code. I don't believe any model will rule them all when it comes to this. There's too much specific nuance to how you build, but have a system in place and a technology that can go with you. And securing through some sort of auto-suggest, auto-fix function is inevitable. We're getting to a place where we could one day be hands-free on the fixing. So code generation and code fixing happens at the same time. So you get your company-specific coding standards implemented inside of any code generation machine. So with that, I'm super excited about AI in AppSec, and I believe when you think about all the vulnerabilities that occur, 100% come from code. If we can predict and prevent security flaws inside of code, you can drop the mic and we can move on, right? We don't have to be burdened with cybersecurity. It can be a natural feature of what we deliver on. So in a nutshell, there's so much upside for AI. We are in the very early stages of code security and implementing this properly and effectively for you as developers and as organizations that develop. But keep an eye on us at Quiet AI. You can absolutely get a free account, get on there, play with it, take a look at some of the detection models that we have for Java and C# and others. and I'd love to get any feedback that you have, so please follow up with me, and thanks again for your time.
Thank you so much, Stuart. We're doing Q&A follow-up today at that high top table here, stage right. See that in the corner? Stuart's just getting the mic taken off, and he'll be right over there. So if you want to ask Stuart any questions, that'll be the spot. And that'll be the same pattern with each speaker. We have about 4 minutes until our next speaker. So I guess a few announcements. We have the main stage here, workshop room 3. If you pull up the agenda, AIuserconference.com, if you're curious, workshop room 3 is right there. So Cloudflare just began their workshop. Workshop rooms 1 and 2 are downstairs. So if you're Pro Pass holders, you can check that out. Other activities, go see our sponsors. We got CodeRabbit right over here, MongoDB, AirTrain AI, Canva, Cloudflare, Convex. On the other side, we have Lightning AI, UiPath, Simplified, and Anyscale. So please go visit our sponsors. We really appreciate their support, and we'd love for you to engage with them. We're going to start on time, which means we have about 2 more minutes. Bear with me. And we'll hear from Matt from Respel shortly. Thanks very much. Okay, everyone's awake? Good. Please help me welcome Matt, CEO of Respel.
All right. Whoop, wrong slide. Hello, everyone, and thanks for coming out today. I know you're probably tired from all these technical talk, so I'm going to give you a bit of a break. Think of it as maybe a bit of an intermission. I don't have a talk going into the deep technicals of multi-agent orchestration or how to deploy applications into enterprise. But I am going to give you some mental frameworks, hopefully to get you into a bit of an automation mindset. Think about, give you the language to talk to your team about this. And for the builders out there, we've built a lot of really fascinating stuff under the hood. So if I have some time at the end, I'll be talking about how we did some of that. I always like engaging the audience a little bit. Would love a raise of hands really quick on just, and you can raise your hand for both, whether you are here to learn about how to use AI, either for yourself or for your organization. Can I get a raise of hands? Okay, versus maybe building it more for others, whether as projects or founder. Great, okay, so about an equal split, perfect. So a little bit about me. This is my second startup. My last one was custom home building, and that was a bit of a detour because most of my career was spent working with AI and the whole data space at large. This was back in, let's say, 2012 or so when I started training my own models, getting my own data, scraping it, or downloading CSVs from the internet, and it was really fun. And that's a joke because it was actually really awful. And nowadays, things are much easier. Everything's an API way. You can build a lot of really fascinating stuff. But it wasn't always that case. And some of those skills do transfer, but we're in the golden area. There's a lot to build, so many new possibilities that hopefully I can show you a few, but it's a lot easier now. So just hold tight. Respell, quick TLDR on us. We do AI automation. So most of that comes into workflows. I'm going to be defining what a workflow is in a moment. But that is anything structured you do day-to-day work. You can compile most things you do into a workflow. Checking email, responding to messages, even coding. There are workflows to that. Generating something creative. Everything's a workflow. And my goal is to give you rough mental framework on how to think about how to break it down and actually use AI for it. There's lots of pros and cons and things it can and cannot do. We started about a year ago, and one of the first things that we had to deal with was, what does it look like? How do we get AI into people's hands who have never heard of it before? And even today, we still get people who, they tell me, I've just found out about ChatGPT, like, how do I use this to do things? And to me, I've been in space, so it's incredible to hear that anybody has just heard about ChatGPT. But that is the reality for most businesses. They still don't know. And you have to have the right way to pitch it to folks in order to make it click in their heads. So talk about form is the first thing. This is my schema. You may have a different one, and these are also fuzzy boundaries. But I like to think that there's roughly 4 types of AI that you can use day to day. Everyone knows what a chatbot is, ChatGPT, Microsoft Copilot, Bing Chat, or whatever they call it now, and also agents and like the GPT store. We know what a chatbot is. It's free-form conversation, and some problems fit really well in a conversational interface. Some are terrible for it, though. Like, I don't want to. I want to have a back-and-forth conversation if I'm trying to do something creative. I don't have maybe the specifications in my head on exactly what I want to do. Maybe if I'm writing a story, for example, suggest to me some ideas. I'll correct you or pick a choice. But I don't want to argue with my computer on every website that I go to. And so I think the natural tendency to reach for a chatbot as the end-all be-all solution for interfaces, make sure you know your other options. The 2 next ones, micro apps and automations, they're very similar. And I'm all about workflows. That's what I think about day in, day out, and what I dream about most likely. But there's one difference between them, which is whether they're initiated by you or whether initiated by some other external event. So a workflow is just kind of a structured sequence of steps. And if I'm answering an email, well, I have to think about the context in that email. I have to decide, if it's a yes or no kind of thing, how I want to respond, and I got to actually write it and click send. Right? That's, let's say, 4 steps. And if I wanted to automate that, I could with AI nowadays. Previously, it was pretty hard because there's a lot of thinking involved. But you can offload that now. And so that's something you could automate. And a micro app, on the other hand, is maybe something like writing a story. Maybe if I don't want to do a chatbot, I want something, my template for give me my story idea generator. That's a micro app. It can do a lot of the thinking, but I'm the one that triggers it because I don't I have a thought one day. I'm like, I want to write a story. There's no like external stimulus there. And then finally, there's embedded AI. This is kind of the wild card category. Every tool is building in AI, Notion AI Assistant, Canva and Figma. They have AI features now. Every website is scrambling to get some kind of AI in there, and it takes different forms. But you can't affect that. You have to be in there as a developer to build it. So that's something that, as a user, you might want to be aware of. But if you're building something, you can't affect that. Now let's talk about function. Again, high level. The schema may not work for everybody, but the top use cases that we see for workflows are pretty clear, and there's definitely a very strong drop-off after these four. Research, generation, analysis, and decision making. Decision making is the odd one out, which I'll spend a bit more time on that. Research is, I think it's probably the most common workflows that we see at Respel, is like people research. It takes an absurd amount of time to when, let's say, a new applicant comes into your company or a new contact signs up for your website. Somebody new, you want to know who they are, you want to grab their attention, you got to do some research on them. Those are by far the most popular automations on Respel. And a very close second is generation. I don't think I need to spend much time here because it's called generative AI. Everyone knows that we can create text, we can write code, we can generate images and sometimes videos too. So that's a pretty obvious one. Analysis is tricky, and I don't even talk to customers about analysis because it means something different to people. When you say analysis nowadays, a lot of folks think, oh, big data. I can just toss a 30,000 row CSV into my AI model, and it's going to fix everything that I want it to do. It can crunch the numbers, calculate some complex things, and it's not how it works. So analysis really comes down to when you have data, let's say on a small scale, and you want to parse things out of it, so field extraction, or you want to classify it, or you want to transform that data, maybe go from, like a small sentence into a bigger sentence, add some detail. That's the kind of data analysis or like data engineering-esque things that you can do with automations, and that's definitely number 3 on the category. And the last one is decision making. Decision making, it's interesting because it's our natural human tendency that we don't want to give up control to AI. If I'm deciding whether, in the recruiting context, whether I want to accept or deny this candidate, that's something that, first off, like I'm a very empathetic person, so it feels bad if I do that. But also, I don't know if I trust AI yet. And we're kind of at the uncanny valley where trust is a huge factor in no matter what kind of workflow you're building. Trust is probably the number 1 concern. Because you have to look at what kind of percentile or what kind of percentage risk am I comfortable with. If it messes up 1% of the time, then decision making, oftentimes you can't do anything there. But if you can get to only mess up 0.1% of the time, some more opportunities open up. Now decision making, in its broadest form, is probably one of the most powerful ones. And at Respel, we don't actually support any decision making use cases, but it is probably the most asked for after those top 3. And people want to give control to the AI. So as you're building things, experiment. Talk to your users, like which one of these 4 or other buckets that fits into, and see if you can also make decisions for them. Because that's how you actually get past the barriers for a lot of these automations. All right, so this is the abstract stuff. Now let's go into Workflows 101. What are they? How do we use them? Common use cases that we see, and try to get you into an automation mindset. First things, definitions. Got to set the language at a base understanding. Workflow is multiple steps. Doesn't need to be linear. It can be all kinds of winding paths, but it has specific tasks that, I'm all over the place today, specific tasks that are custom to your business logic. And so this could be, like I said earlier, answering an email. It could be generating content. It may have multiple steps. It could be whatever else you're doing day to day. It's completely dependent on what you, in your context, need. And then there's some input or output or effect. Outputs and effects, maybe it changes something in the system, updates my CRM or my ERP. Or maybe it just gives me some kind of data and sends it to me on Slack or my communication channels. Now, an example that is probably one of the most concrete ones I show to most people is screening a candidate. Very custom to your business, but this is kind of the flow that I go through. I will first look at a resume, and usually it's going to have their personal website or LinkedIn on it. So I'm going to go to those. I'm going to Google search their name, find everything I can about them. I'm going to write some notes, accept or deny, and then send them an email with that result. And if you think about, let's say 3 years ago, how you would have automated this. Well, looking at the resume, we had resume parsers. It would get like the keywords, which is why most resumes have like the skills with a bunch of keywords on them now. It's to get past those ATS screeners. And then you'd probably manually have to go Google search their name, look at their LinkedIn, make a decision yourself, write some notes yourself, and then send the email yourself. And you can maybe use a template for that, right? And sometimes your ATS applicant tracking system, by the way, might have that functionality. But now with AI, you can do a lot more. And the last one in there with Red, you could also probably do that. It's just a matter of, again, the trust making, or the trust and the decision making. And I've automated this for Respel, so I know very in depth on that this is possible. And I can say, it's not nice because it saves me time. It's nice because I have other things to focus on. And that's the key thing with automation. It's more than just the time you save with each individual thing. It's about when you combine them all, how many times a day do you get distracted and then have to lose your train of thought and go on to something else? You need to knock out as much as you can in order to stay effective and in control of your time. And so with AI, I mean, you can do the research online. Like we have a research agent that just does that for you. You can scan the resume, have AI think and make a decision on it if you want to, have it write some notes if you don't want it to make the decision for you. And you also have it send a personalized email back to them. So at least you have the good impression, you get the goodwill. Now, why bother? There's a really great XKCD comic, which I forgot to put in the slides, on this. And the x-axis, it's a table with the x-axis on, I believe it's how long something takes you, like each time, and how often that thing happens on the y-axis. And in the table, it shows you how long you can spend on building an automation in order to get ROI. So look that up, just do like XKCD automation after the talk. But my math is that I go through roughly 50 of these a day. And I don't look up and go in depth on each candidate, but it takes roughly like at least a minute or two if I really care about them. And that's about an hour every single day, which does kind of check out with how I do it. So just by going through this, and it took me about, let's say, 2 hours to do, that's 2 days ROI. It felt great. In general, some tips for automation, and this is probably one of the more critical slides in here that might have a takeaway. Whether you're building something for users or whether you're trying to automate something yourself, you need to understand, okay, what's the form and function, so the form factor, the interface you're using, and then also, what kind of AI are we using? Is it focused on research? Is it going to be generating something? Because there's tools for each specific one, and Respel is not going to fit all of them. But you might use Perplexity for research, or you might use ChatGPT for generation. So pick out your right tools, because it will save you a lot of pain later. And write down the full process. Like actually get out your pen and paper and write it down. One of the most surprising things to me when I was starting Respel was how most folks don't think about the nitty-gritty details as they're going through these things as they do them. You're thinking about, I ask, let's say, a recruiter, what does your day-to-day look like? They're like, oh, well, I answer emails and I schedule meetings. That's not all they do. They do a lot more than that. And the devil's in the details. And if you want to automate something, you actually have to get them to write it down. You don't want to skip on that part. Time-consuming first. Those are usually the meatiest ones. And I think you might be surprised on what you can do there. And don't be afraid of human in the loop. Decision-making is tough, even for AI. Like sometimes it'll make mistakes, and that can cause you a lot of heartache. So don't be afraid to have a step where it asks you for confirmation or asks you for feedback. And last thing is, be aware of limitations. I feel like the rest of the talks here give a pretty good overview on that, especially the last one. Some of the most common use cases we see, and the clinger here is every single function has something you can do. Even engineering, I know the engineers in the audience, you have a lot of power because maybe some of you even got into the industry by being lazy and automating some of your tasks that you were doing on your own, because I was that way. But it's all the other stuff too. Bug reports coming into Slack, you got to deal with that. That doesn't need to be the case. You can automate that part too. So everybody has something to do. And the most common ones we see is for sales, lead management. That's people working with people. Sales is a people function. But before a year ago, there weren't really good tools for looking up folks and researching them, understanding what they're about and what they're asking you for. And so that's by far probably number one in general for Respel is lead management. Recruitment, same thing. Anything to do with HR, also a people function. Operations, this one's interesting because operations means very different things to different companies, but one of the most asked for and one of the most run spells for Respel is looking at competitive analysis, market mapping, doing general research. So again, in that top bucket, research. And then data analysis. It's actually surprising me how many folks don't realize that one of the things that AI is very good at is going from natural language to another structured language, whether it's SQL, whether it's some proprietary like filter language in Notion or HubSpot or Salesforce. And one of the easiest things for us to do is say, hey, you can query your database with English, or you can query your Salesforce with English, because nobody knows how to use their SOQL language. So those are really quick wins, and if you're looking for something to tinker with, highly recommend natural language to another structured language. All right, so quick thing about Respel.